Intelligent Generations V1.0, which is having to do with AI and Rhino mainly, various AI tools. Just also want to remind everyone that this being an AI webinar and all these tools being new and kind of beta, that you can probably expect, you know, some bugs and hiccups here and there, but we'll go with the flow and get these things going as best possible. It's always a lot of fun when you're messing with the AI, if you haven't played with that kind of stuff before. Alan is a director of computational design at unedited Architects. And Alan is a computational designer, artist, and educator in New York City, currently as the director of computational design at unedited Architects. His work focuses on parametric architecture, complex geometry, sustainability, robotics, 3D printing, and simulating natural behavioral systems. Alan utilizes his expertise in generative and computational design to take an experimental approach to the design process, where he imagines speculative futures and incorporates advanced digital fabrication technologies to realize complexity. Alan also teaches at the City College of New York. So welcome, Alan. And before you get started, just want to remind everyone here that if you're chatting in the chat, please switch it to everyone. That's for you also, Alan, in case you wanted to share some links as you're going. Just make sure that you change the chat to everyone so that they see whatever you're posting. And if you have any questions during the webinar, please use the Q&A button. If you look at through your buttons, your Zoom buttons, you know, where all the buttons are basically, there's one called Q&A. So if you click that, you can ask questions there. It's just easier to keep track of than if you're asking questions in the chat. And that's where Alan can look at those questions and answer them as he can. Lastly, just a reminder that after the live webinar, you'll get an email with a recording link, which was described in the registration form. To also make sure that if you don't see it within 24 hours, also check your spam folders. Just a reminder that not everyone learns at the same pace, and we want to give you as much content as possible. So if you feel the webinar is too fast for you, or maybe you're just not getting it right away, feel free to sit back and just watch and come back to the recordings afterwards. With all that being said, I think we'll hand it over to you, Alan, if you want to start with sharing your screen, just to make sure that's going, and then we'll let you get on with it.
All right, sounds good. Thanks, Michael. Thanks for the introduction. So I shared the Dropbox link for the workshop. See if that works.
Yeah, it worked for me.
Cool. I'm also just going to share some of these stable diffusion download links. I'm not going to go over the installation, but I will copy these. Hopefully folks are able to get this stuff installed. Then one more is the models. Okay, that's stable diffusion. So just to give everyone kind of a gist of what we're going to do today, some of it, you know, we're going to start just by looking at some sketch ideas in MidJourney. I know everyone hopefully is probably fairly familiar with MidJourney these days. And then the real kind of meat of what we're going to do is ChatGPT to generate Python code, and we're going to be putting that into Grasshopper. So as Mike said before, the nature of AI, a lot of this is pretty experimental, so we might have some hiccups. I've kind of planned this entire webinar to kind of go with the flow and see what happens. Hopefully things go as intended, but you know, we can wing it as we go along. I also, so the files that I shared, I had some kind of pre-made examples just in case some things aren't working out as intended. So we have some things to fall back on. Let me share. Okay. So
We see your screen fine.
you see? Okay.
Yep.
Cool.
So I'll be here in the background.
Awesome.
I'll let you go to.
Cool. Cool. It's going to be hard for me to check chats, but I'll try my best to. Okay. So just a few things. These are in Grasshopper and GH dependencies here. These are plugins I think we're going to use. So go ahead and install these in Grasshopper. You do this by putting them in your libraries folder. So some of these, you got Pufferfish that Mike wrote, Dendro. I have Human for display things. Weaverbird we might use for a few mesh smoothing operations. Ankylosaurus, that's my own plugin that I wrote that is not publicly released, but I'm sharing it. This was kind of an old version. I wrote it in 2017. So some of these things have also been incorporated into other plugins by now, but there's a few utilities in there that I like to use. So that, feel free to install and look at that. Okay, so I wanted to call this webinar The Joy of Generating or something along those lines, just as an ode to Bob Ross. And I think one of my motivations for that is a lot of like how I use AI, and I think maybe other people might use AI, is it's very sketchy in a generative way, and you can rapidly test ideas and work through things. So one thing that I've always thought was cool about Bob Ross, that he was able to rapidly, generate landscapes very quickly using really a centuries old technique called alla prima. So alla prima really just means keeping the paint wet, so you can continue to move the brush around in a very fluid way. It was a popular technique among impressionists at the time when they were really kind of kicking off that style. So it's not necessarily a one-to-one with alla prima. We're not working with paint. We're working with pixels. We're working with code. We're working with 3D information. But kind of the spirit, there's two ethos I thought were good to kind of get from Bob Ross in this. And one is this like fast generative style. And then the other is he emphasized that anyone can do this. So I am pretty adamant in thinking that anyone can do this, especially with AI. I think it really lowers the barrier of entry to using computational design techniques. Like you need to know just enough Python, to use ChatGPT to generate Python. I think you don't have to like actually consider all of the algorithmic steps that, maybe traditionally people like me and Mike had to do when we were learning this stuff. Like it's really acts as like an extra bridge in being able to learn some of these kind of computation techniques. So that is what we are going to look at. All right, so the first thing, I just wanted to take a look at MidJourney, show some of the things I think most people are familiar, but we're just going to start here to get some ideas going. So this is Discord. MidJourney operates in out of Discord. It uses the server to kind of, send up and give us images very quickly. So you can see some of my other stuff on here. So one of the things is we'll do the imagine. So anything with MidJourney, you type a >, and let's just, maybe I'll delete this for a sec. We hit backslash, different things come up. You can access the settings, you can access Imagine, you can ask it questions. There's these other things. There's also documentation online that kind of, it really just does a good job of explaining all of these settings. So one thing that is cool about MidJourney is it is a generative diffusion artificial intelligence model. So we basically give it a text prompt using this Imagine feature, and we can generate images from the text. So maybe I want to do a boxy, maybe a random box skyscraper in a cyberpunk style. Okay, so that's all I need to do. I'll hit enter, and this will send it to MidJourney and start to generate an image for us. So a couple things while we are waiting. I mean, one thing that I really enjoy about MidJourney, Stable Diffusion is a very similar type of generative AI, but they are different in kind of how you use them. This might take a little longer because we're screen sharing here, but that's fine. I find the newest version of MidJourney really kind of creates the cinematic and high quality feel, like with very little text. Whereas older versions of MidJourney, I felt needed a lot more prompting, a lot more kind of signifiers. You needed to say things like 8K or 4K or seen on ArtStation. Things like that in the prompting that would kind of help get better quality results. Whereas like the newest model of MidJourney, version 5, is much more fine-tuned to kind of giving us those high quality results. So we can kind of see this one I did yesterday, much higher quality than some of the older models with very little text. All right, so while that's waiting, maybe I'll just imagine another prompt. A biological. So we're going to look at a few things and kind of maybe two different stylistic techniques today when we're doing some of this stuff. One is this kind of boxy orthogonal aesthetic, but then we'll also look at ways, and we'll do this in Grasshopper as well, but we'll also look at ways to, you know, make these things a little more organic and feel more like some of the organic imagery that was shared in the promo content for this webinar. Organic coral building facade. And maybe I'll change the aspect ratio. So you can change the aspect ratio. The syntax for this is a dash dash. You can do AR, and then I could say something like, maybe let's do 4:5. Okay, so that will send. So now it's generating that. So I can look through some of these things that I did the other day. Some of these, just a modern random box form office building on a city street. So just kind of showing some of the process here. Yeah, so a randomized box skyscraper city. So some of this, you know, I was seeing some of these results, and this one was a little more cartoony. I wanted something more like photorealistic, so I did change. So I went from a randomized box skyscraper city to maybe something more like an office building in an urban environment, because I was trying to get this to be less of a cartoon and more kind of photorealistic. When I changed this to office building, the text prompt, it was still a little, it was giving me more like anime style cartoons, like maybe that one is less so, but it's also less kind of formally interesting than what I was looking like. These are more formally what I was after, but stylistically in the image, not necessarily what I was after. So when I changed it, I think the keyword here was modern on a city street, change it to office building, then it was starting to give me more results that I was looking for. So these are just some of the things to keep in mind when using MidJourney. This was an organic coral facade version. So a highly detailed organic biological coral building facade. Okay, let's see. Looks like we've generated a few of these here. All right, so MidJourney has some of these are pretty cool, cyberpunk, sci-fi. This one's like less of a scene, but I didn't even specify what that scene would be, so it just gave us something here. So what we can do is we can hit upscale. Upscale 1 is going to upscale this image on the left. Upscale 2, U2, U3, U4, that's going to upscale these images here. So I'm just going to do all of them. All right, so it's pretty quickly V5. It used to take a while in the older versions of MidJourney to upscale these things. V5 is relatively quick. So these are my cyberpunk options. Let's do upscale all of these too. These are our organic coral options. So the reason we're using MidJourney to start with, it's really like the way that I see MidJourney, it's this sketchy kind of artistic tool for us to really rapidly generate ideas. I mean, so far we're already super quickly testing these. I've got, 8 interesting ideas going on just with a couple of text prompts. So MidJourney is really just an awesome kind of idea generator. Like a lot of people, you see share a lot of this stuff maybe is final imagery, which, maybe we might arrive back at that through some of our experimentation. But really what we're going to try to do is use this to kind of get an essence of like, that looks pretty cool. Now, how can we, use other AI tools like, ChatGPT to help us generate some of this stuff as a 3D model in Grasshopper. Okay, so maybe let's say this one, there's some characteristics, I kind of like that one. All right, but let's say there's some characteristics in this that I like, but I want to zoom out. You can actually, in the new MidJourney, you can say zoom out 1.5, zoom out 2. Maybe let's go for a large zoom out. That's going to regenerate some stuff for us. And maybe this one, I want to see some variations. So I'll get some strong variations. And, what's kind of cool about this is it's super variable, not much repetition. It's kind of hard to understand or break down the fundamental logic of this, but, we're going to try our best to do some hybrid techniques for some of this stuff. Okay, well, that's going. I really enjoy the zoom out setting. Okay, it's still thinking there. All right, these are all pretty cool variations. Let's blow them up. All right, so interesting when you zoom out by a lot, what kind of results you get. The zoom out is a good feature because a lot of some of my earlier studies that I was doing before they added that, I always felt a little too honed in, almost too focused on like one small piece. And I remember thinking, man, I really wish this would zoom out a little bit. And I tried to craft the prompt so that it would do it, but nothing really quite worked. So now that they added this feature, I find it super helpful. All right, so that's I mean, some of this stuff you can kind of like on this one in particular, what I like to do is I like to see patterns in this, and I like to think of ways that I could break down the logic. Like if I were to make a script or a system that would mimic this, I would probably like what this looks like is some sort of Voronoi pattern, thickened lines, and then it's got some extra things like these blobs here. Like, you could either ignore those or think of ways to kind of incorporate these little kind of lump cells in here. But one thing that I enjoy about, using MidJourney in this way as kind of a creative, really a idea spark, is what it allows me to do in my process is think about ways that, I might not, it's like I might know some techniques to get at something like this, but because of how, as a diffusion model, it just combines things in a very random way. And it kind of gives you things that are not necessarily expected. So it makes me think about things in a way like, oh, I could actually take two different systems and apply them together and come up with something new than just, keeping one system at face value. So I think that's been something super interesting for me. So we can, at least try to get there at a basic level today. And, I mentioned randomness. We're really going to focus a lot on randomness today and using that kind of as using randomness in creative ways is something that I'm always interested in doing. And because of the nature of AI, a lot of this can be very random. All right, so I think for now, these are some things like we kind of looked at some biological examples. These are very interesting. We can see some cool cyberpunk examples, a lot of boxy forms, regular shapes stacked on top of each other. So I think we started in this zone here. Got this kind of logic going on. So let's try to start with that in ChatGPT. All right, so ChatGPT. I'm sure a lot of people have heard of this. It's kind of one of the main it's one of the biggest large language model generative AIs, so an LLM. And it's pretty useful in that you can ask it all sorts of things and kind of even use it as a learning assistant. So yeah, one of these Bob Ross's painting style, we can ask it that. So we can say, what is the painting style of Bob Ross? All right, so it gives us some tips, tells us alla prima, wet on wet painting, tells us some other facts about Bob Ross, which is pretty cool. We can ask it to describe the technique of alla prima. Okay. So there's lots of things. So I use ChatGPT a lot for, even drafting up text ideas, drafting up all kinds of things, but my favorite thing to use it for is generating code in Python. I guess just a note on that, why Python versus other languages. I mean, it's very simple, so it's pretty easy to work out bugs. You can also use ChatGPT for C#, which, if you're more into development in Grasshopper and Rhino, C# generally tends to be the way to go. Mostly because it's what the software is built on. You can compile proper plugins that way, whereas Python, you're limited to user objects, which, if you care about efficiency, is less efficient in terms of its running. But we're going to use Python components, so we can make our own custom Grasshopper components. We don't necessarily care about efficiency in this. We just want it to help us as a design tool. So I'm going to, and by the way, I'm going to be using ChatGPT 3.5 for this. In my experience, 3.5 is better at generating code that is useful, whereas GPT-4, even though it's more sophisticated in terms of its reasoning and kind of being conversational while you're using it, it's less good at, I found it's less good at giving me useful Python code. So we will be sticking to GPT-3. Okay, so I'm going to ask it first. I'm going to say, are you familiar with Grasshopper 3D? And it will say, yes, I am familiar. Grasshopper is a visual programming language, environment for Rhino. Yes, very popular 3D modeling software. Yep, none of this stuff is contentious to me. Widely used by designers, architects, engineers. All of that is true. I'm going to tell it thanks. So when the robots finally take over, if you're polite to them and say please and thank you, they might spare you. All right, so thanks. Are you familiar with Python? Or I'll say the Python programming language. Okay, so Python, high-level interpreted and general purpose programming language. Simplicity and readability. That's what we want. Okay, so we can use Python and Grasshopper. Can you tell me how Python works in Grasshopper? Okay, Python component, you write code, there's input-output parameters, and I might as well pull it up while we're looking at this. So I'm going to go ahead and open up Rhino. And just go into perspective, shaded viewport, and I'll open up Grasshopper. So if you haven't yet, please, in the folder that I shared, please install these plugins as dependencies. You can just copy these folders directly and paste them into your libraries folder. So if I go to here, special folders, components folder, and paste them in here. I like to keep them organized in folders because it's much easier to keep track of. So anyway, please copy them in there. You might need to come in and unblock it. I don't know. So always right click and unblock. And if you do that, you will need to restart Rhino and Grasshopper. So you just have to restart and reopen. Okay. So I'm going to get a Python script component. Here's my template. Okay. So Python. Let's see what ChatGPT is telling us. So allows us to extend the functionality of visual programming because we can script directly into a Python component. The nice thing about Python is it allows us to access all of our Grasshopper data. We can access anything that Rhino has in general. So like all of the commands that are available in Rhino and in general the coding language, we can access through a Python component. So you really can do a lot of things that you might not be able to do just baseline out of Grasshopper. Now, I am generally pretty adamant that most things, like given plugins that others have developed, you can pretty much do most things in Grasshopper that you could do without scripting. But the nice thing is now that we have this cool kind of AI assistant in ChatGPT, we can really take advantage of that and extend kind of the power of Grasshopper by helping us with Python components. So I will say in my work, I'll even, ask ChatGPT to make me quick utilities that, it might take me an hour to write in code, but, with ChatGPT, it can be a matter of 5 to 10 minutes to get that done. So yes, always polite. All right, so this is Python. It has inputs. By default, there's an X and a Y input. The output is A. So just like any other regular Grasshopper component like this, you have inputs and you have an output. So each of these components, it does something very specific. So A plus B, the addition. There's code inside of this component that makes it do the thing that it's telling you it does. So this is basically a blank canvas, the same way Grasshopper canvas is blank. We can click into here if you double click it, and this should by default show up. It should give you your username. I don't know why it cuts off my last 2 letters. And it will have, it'll be importing a library. So basically with Python, the same way that in Grasshopper, we have these tabs at the top here that are plugins that we've installed. Well, Python works that way by importing them as libraries. So we can kind of access, let's say, you call them libraries or modules. We can access that, basically these plugins by saying import, and then we can, give it some text. So that kind of allows us to access all of the commands that a plugin might give us. Okay, so let's just start out with something fairly simple. I'm going to go to a new chat and I am going to ask ChatGPT to make us a random box. Can you please make a random box? Can you please make a Python? Sorry, you have to ask it right. Can you please make a Python script for Grasshopper 3D that outputs a random box? All right. Interesting. Well, sometimes it tells me I cannot code in Grasshopper 3D, blah, 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 and it tells you, but then it says it can help you. Okay, so let's see the nature of this. So it's telling us it'll use the Rhinoscript syntax library. It'll tell us a few things. It even gives us steps on how to open Rhino. Type edit Python script, which is not really what we want to do because we actually want this in Grasshopper. So some of this is not entirely accurate. So you do kind of have to know just enough to not necessarily, like this is basically telling us how you would do it in Rhino. And you don't need to, oh, interesting. I don't even think you necessarily need to do that because it kind of comes automatically. Anyway, so now it's telling us, okay, you can open it in Grasshopper, use Python script. Okay, so most of the time I don't even read most of this stuff. I just go straight to the code, I copy it and go right into Grasshopper. So what I'm going to do is just copy over all of that stuff. This may or may not work. We will find out really quickly. So I can go ahead and test that. And I can tell it already doesn't work because I get an error. Unable to create brep from box. So one thing that I do in this process is I always have a panel generally that I use here as an output to see what the errors are. Okay, I'm just going to delete that. Generate random box. Whoops, don't want that to be that big. Okay, so the first thing is I personally don't like to use Rhinoscript syntax. I like to use Rhino Common. So first thing, instead of even trying to debug Rhinoscript syntax, I'm going to ask it to use Rhino Common instead. And Rhino Common versus Rhinoscript syntax, just to give a little bit of background. You know what? Why don't we ask ChatGPT? Is the difference between Rhino Common and Rhino? Okay, so ChatGPT can tell us. They're just different libraries. Rhino Common, basically Rhino Common is what Rhino is built off of. It's the libraries that, you know, a lot of the commands and functions run off of, while Rhinoscript syntax was kind of packaged up to use some of those commands and make it a little bit easier for people getting into scripting for Rhino. I would say it's a bit of a holdover. Like it was used maybe in the early days of computational design before even visual programming was a thing. So I don't know, when I'm coding, I tend to like to get more into Rhino Common, so you actually know the functionality and utilities of what you're doing. So in ChatGPT, long story short, is I just like to use Rhino Common. So I'm going to ask it to generate the random box with Rhino Common. So I'm just going to copy my first question. Can you please modify the Python script for Grasshopper outputs a random box to use Rhino Common instead of Rhinoscript syntax. Okay, and then the typical thing that it'll do, it'll say rhino.geometry as RG. And RG, that's just when you call a command, instead of saying rhino.geometry every time, you'll say RG dot whatever the geometry type is. In this case, it's a point 3D. This might already be wrong. I think it might need a plane and not a point, but let's give this a whirl. So I'm going to copy the code. Sometimes I take the component and I copy it since I'm rewriting all of this anyway. I'm just going to replace this code and now I'm going to test it. Okay, so we still get an error. Expected interval, and we got a float. So line 17, we can look here. Okay, RG interval. So it's just saying 23 in script, because what it's doing is it's creating a definition. So in the land of coding and in Python, we can think of these things like a definition, like it's kind of like a Grasshopper component. So a Grasshopper component is something we drop onto the canvas. Well, this is like creating a reusable version of code. So we're basically taking that and we're saying random box equals generate random box. And then it's what that's doing is it's calling the code here. Or it's calling this code and using it here. So we could use this over and over again in the script below. So yeah, I mean, it's because we're giving it a number. This is a random number between 1 and 10. What an interval is, that's the same thing. It's the equivalent of a domain. So a domain here, 0 to 1. So you get that thing that says 0 to 1. Well, in Python, that's basically what that is. So we could manually do this. We could ask ChatGPT, like I could copy this, copy data only. I can bring this into ChatGPT and I say, I am getting the following error. Okay. Let's see. I don't really think that's fixing our problem here, because it's not actually giving us an interval. It's giving us the exact same thing. I'm going to regenerate that response. So this I can already tell it's giving us a double. So, okay, double. Oh, but the double is an interval. But it's still passing it incorrectly. So, all right, I'll spare us here and I'm just gonna try to fix this manually. 1, 1, comma. Okay, create instance. So it takes at most 4 arguments. I think what really needs to happen is this needs to be, instead of a point, it needs to create a plane, which I think it's kind of confused about. I'm just going to ask it to remake a random box. Let's try this one more time. When I did this, when I tested it the other day, it just worked. And if you are following along and kind of seeing what I'm doing here, you're definitely not going to get the same results that I am. But maybe, can you share chats? Anyway. Okay. So this is definitely even more wrong. I'm gonna regenerate. Sorry, I can just tell that it's wrong already. That's okay. That's why I have a fallback. Not great that are the easiest example. It's giving us trouble, but that's cool. All right. So in the fallback, I have this file called 0 ChatGPT random box. I'm going to go ahead and open that file. I'm going to close this. Okay. So ChatGPT random box. Let's just look at what's happening. So this made it by a series of points. Yeah. So the interval, the correct way to do an interval is it needs 2 values, it needs a plane, and then it needs the intervals. That's how we could kind of tell that the other one was wrong in the way it was generating a box, because it was putting a point here. It can't take a point. It needs to be a plane. It also needs to be intervals, and it was giving it vectors. So it was very wrong. So one thing with this random box example generated here, it gives us, we're doing a seed. So the first thing, I'm just gonna copy and paste this really quick. I added something manually to this, and what I added manually here was a random seed. So I'm just gonna hit OK here, eliminate the seed. Let me just turn this off really quick. All right, so the reason you need a seed, let's just eliminate that for now. If this was what it gave me something to output a box. Also used Rhinoscript syntax. It allows you to set a width range. These are things that we could pull out actually in the Python component to have control of if we wanted to. And I'll show you how to do that. Let's say if we wanted this to be intervals that we pull out. So, okay. So I'm just going to go ahead and delete this seed line as if it didn't exist. Hit OK here. So this is just a point. I got this to show as I move this along, you see that it changes every single time. Well, that's because the way that random works is that every single time this component reloads, so if I change the input at all, if I take this, plug it in, it's going to randomly regenerate our box every single time. So there's no registration. It's just purely random. It's just constantly jumping around the values based on our definition here, which, where is it? This random.uniform. So it's got the width range, the height range. It's looking, so basically what random does is it takes an interval and it gives you a random value within that domain. Okay. So what we need to do then is, let's just say that's our definition for creating the box. I don't need that. When we're using random, it needs to import random here. So I have an input. So our inputs here right now is an input plane. One thing that needed to happen is, let's just say I got this code and nothing was actually connected here. So let's just say this was the code I got from ChatGPT. This would have been X. This would have been A. All right. So I just took this and I copied it in, and this is how the code came out. So the first thing is our input plane is, it's a plain input. So right now our runtime error is probably that it has no input plane. So there's no attribute origin. So we don't really know what's happening. So I can plug my input plane into X. Now the problem is it has no way of registering that because X is not a variable here. So what I could do is I know that input plane equals rs.coerceplane plane input. This is actually going to be my input. I'm going to control copy that, and I'm going to control paste that here. Okay, and then I'm going to test this. All right, well, that's good. I've gotten rid of the errors because now it knows that it's a plane. Another thing that I need to do is, you have item asset access, list access. We'll get to that in a little while, but really what that's asking for is, is it a single value or is it a list of values? You can also do it by tree. We're not going to get that sophisticated. You can also set the type. So the type hint, right now I had already done this. So usually you might have no type hint, or GH, I think it has GH doc object with geometry. That's usually the default. But I like to be explicit about it. So it's always good to be as explicit as possible with your variables. So I know that the input needs to be a plane. I'm just going to select plane there. So when I go to type hint, it's going to look like a plane. Okay, so that's cool. Well, now I output, but that's null because this is A. So there's actually nothing coming out of here. Well, it's because our output, we either need to say A equals result box, or I could just copy this box output and replace A here with box output, and it will name my variable. So now I hit test, and now there's my box, and I'll hit OK. So we're back still to the problem where this changes randomly every time the input changes. So this is where we need to give us a seed. So I'm going to hit here, instead of X, I'm going to call this seed, and I'm going to plug in this value. Well, right now it doesn't matter because the seed, there's nothing happening in the code that identifies what seed is. So all this is doing is it's an arbitrary input that is connected to nothing. Now it won't give us an error because technically it is correct in terms of code syntax. So I'll just go ahead and minimize this. So where it says input plane, well, we can also use this to define seed. So what we can do is random dot seed, and we don't even need to say like anything equals this. We can just say random dot seed and give it our seed value. And I can test that out. And what that does is now that when this changes, it will always be the same random value for each one, because it's going to be basing it off of this seed. So if I change the seed, it's going to change our shape, but if I change any of the inputs, it's going to maintain that same seed. So seeds are super useful, basically essential when we're doing this kind of computational design using random. Yeah, seeds are absolutely crucial for this. So another way we can look at this is using the random component, right? So right now you get one value. The seed is by default at a number. You get values from 0 to 1. If I change the number of values to, let's say, 5, right? So that's going to give us 5 random values. Well, if I change the values, they're the same no matter what. If it's 3, 4, it's just adding values. So the first item is always going to be the same. And that's because our seed is set to 2. If I change the seed to something like 500, now it's going to start changing our values. Okay, so, but the same is if I change any of these inputs, it's going to keep those values the same. Okay, so we've modified this. We have set up a plain input, which was also something that kind of asked ChatGPT to do, is give us an input plane, because oftentimes it wants to randomly generate coordinates. That's what it was trying to do in the last script that we were playing with. Okay, so some other things that we can do manually that we don't need so we've pretty much got ChatGPT to do the legwork for us in this. It spit out the code to make us a random box. But what we might want is we might want to set our own width ranges here, a height range and depth range. So one thing we can do is we can just set those 3 variables. So I tend to just go by the order in which it gives us width range, height range. It's kind of backwards. You know what? I'm going to do width, depth, and then height. It doesn't give you kind of consistently all the time in the order in which you might expect. Okay. So I've taken those and I've made them variables in our input. What I can do then is I can go to type hint. I can change this to an interval. So interval is a domain. I'm going to do that for all of these. Change this to interval. Height range, I'm going to type hint to interval. Okay, so changed all of those to interval. I'm going to hit OK. So right now, nothing's happened. So I need to get a domain. I'm getting a construct domain component found in the math tab here. And I don't know, something like 12 to whatever. Oops. Okay. So width, depth, height. Okay, so you see nothing is changing, and that's because we have one more thing to do. So we've set our inputs. I've changed it to interval. What's happening in the code is this is actually now overwriting our input. So the code is actually taking this, and it doesn't matter what we have here. It's giving us a range of 10 to 100. So the last step that we need to do is we need to start commenting out, and you comment with this hashtag symbol. All right, so I'm commenting with the pound symbol. I hit OK, and now it's changed because we've changed the parameters. So this is really just increasing the amount our random value can be. And maybe we don't want it to be less than, I don't know, something. Okay. So that's our random box. Example, what's cool is we can ask ChatGPT to generate this thing for us, but then we can also kind of, with a little bit of knowledge of Python, kind of work through the problem, edit the code a little bit, and then set our inputs and outputs accordingly. So this is what we will be doing. Hopefully these next examples will be a little smoother because we're not done with random boxes yet. Right. So the step after adding the hashtags, really you comment them out and you hit OK. Yeah, and then you're done. Cool. Yep, all you got to do is comment and then plug in our inputs, and then it'll take this as input. All right. So I'm just going to go ahead and I think I'll say random box live example. So I'm going to save some of my live examples in the folder share so you can access them in case, you're struggling to follow along. Okay. Actually, I'm going to save as. Okay. Okay. Save that. So this is random box live example. Yeah, typically more words and more ways of asking it tend to help. That's true. Like if you're working through it, being as descriptive as possible definitely tends to kind of help get you better results. It's a little harder in like doing this live in front of people, but yeah, typically yes. You are welcome. Cool. All right, so I'm going to open a new chat. That last one didn't give us a great example of a random box, but that's fine. Now I'm going to ask it for something more complicated. Can you please, always make sure to tell it please, can you please write me a Python component for Grasshopper 3D that generates an architectural tower from random boxes. Using the Rhino common library. So basically what I want to ask it is I want to, that example of the random box, I want it to actually make me an architectural tower from random boxes. So hopefully this is going to give me a bunch of random boxes that will in some way be arranged into some kind of architectural form. Okay, so I'll hit enter here. Yes, it'll give me a disclaimer that this is a more complex task than probably what it can give me. Thank you. But it can provide us with a basic thing. So let's just take a look at this, and I'm going to copy this code. I'm going to be using this random box live example. So I'm just going to kind of build off of this Python script. Okay, so in ChatGPT, I think I copied the code here, and I'm going to take this and, like we did before, paste the code into my Python component. And the first thing is I'm going to test. All right, that's expected to get an error, but let's just see what the error message is telling us. Type has no attribute create from boxes. So let's see, line 37. I don't know if we really need this line, so I think what it might be trying to do is convert. Yeah, I think it's trying to convert a box geometry into a boundary representation, which is a brep, which is a polysurface. We don't need it to do that, so I'm just going to go ahead and give us a shortcut here also and modify this a equals tower, and I'm going to test that. Oh, cool. Wow, look at that. Okay. Super interesting. I did not expect it to look like that. In all of my tests, it has never stacked the boxes like that. Okay, cool. Let's see what this code is doing. So it's got a couple functions. It looks like it more or less correctly. What's interesting is, like, when we asked it to do a single random box, it didn't correctly make a random box. But when we asked it to make something more complicated, like an architectural tower, it had no problem in understanding the code that was necessary to make this box. All right, so that's pretty cool. What it's doing the correct random uniform width. It's saying box equals RG box. It even made a more simple type of box than, let's say, our previous example, which gave us a bunch of points, which sometimes it does that. Like, sometimes it gives us stuff that's more efficient. Like, this is less code to make a bunch of boxes than it was to make a single box in the other example that I saved. So I think with anything with code, it's kind of always there's a lot of different ways that you can achieve the same thing. I mean, that's true when you're using Grasshopper. That's true when you're writing code of any kind. Okay. So let's see, the tower generator. So it's getting base points, number of boxes. These are all things that we could expose if we wanted to. It looks like what it's doing is, for I in range, it's creating a box. So it's using the definition to create the random box, appending it to the tower, and then it's actually getting it's creating a new base point. So it's starting with your first base point, and it's actually creating a new base point based on the height. So this box dot z, so that's the z length of your box, dot length. So that's why it's stacking this. So basically, after it adds a box at the origin, which that's, it's at 0.000. After it adds that box, it's getting the z height of that box and creating a new point, basically at 0, 0, and then whatever the z height is. So that's why it's kind of stacking this in a random box way. Okay, so I imagine same deal if I were to plug in a number slider arbitrarily to this. We're not using a seed anymore. So this is very cool. Okay, so one thing that I might do is this output, the tower is single brep. We don't want that. It's kind of confused by that. We're going to take this code and I'm going to build off of this. So thankfully, this example worked for us. By the way, this number is not doing anything. I'm just getting it to trigger randomly each time. So, okay. We're going to take the code. So what I did in the code is I deleted where it said tower brep .rg create from towers. Okay. So I'm going to just copy this code. Hit OK. I'm going to save this so we all have access. I'm going to call this random box tower 1. Okay. All right. So what I'm going to do is I slightly modified the code and it works. Okay, I'm going to tell it thank you. Slightly modified the code and it works. When proceeding forward, can you please use the following code? And then you can just hit shift and enter and it'll give you the space. And I will paste the code that I used. And now it will generate this code. And for some reason, it tells you to do the code again, or like gives you the example back to you as if, you didn't just modify it yourself, but that's okay. Because really all I wanted to do is to continue using this code. Yeah. So I saved this file. This should be saved in the share folder in the example file. So if you have Dropbox installed, you can open this live. I think there's a way. To share. I thought there was a way to share the chat. Well, okay. Let me share the link to the chat. All right, so I changed it from the last time I did it. So you can share the chat in ChatGPT here. Oh, thank you, David. Okay. Cool. Glad the other example is working for other people. All right, so you should have access to the chat if you click this link here. Yes, to everyone. So you should be able to follow along even in the chat that I'm doing. And then you should be able to follow along here. Okay. So I'm going to use this code. I'm going to copy that because I'm going to modify this code. And in our architectural tower generator, let us say, thank you. Could you modify this script so that instead of stacking the boxes vertically, it randomly locates their base points. Okay. Basically what I'm asking is, can it more randomly configure the boxes so that it's not just stacking them on top of each other? However, one thing that I might want to try is in this code, I could just see what it looks like if they're stacked on top of each other. I could change that z-axis to just 0, 0, 0, like the original base point, and hit OK, which actually might give us some interesting results. So just going to give this a little color so we can see it. All right, so I asked ChatGPT, but before I get into the ChatGPT example, all I did here was switch this so that the base point was always at 0. So basically what it's doing is it's creating us random boxes always at the origin. So it's kind of making this stacked box tower effect, which is kind of interesting. So width range, so it's giving us that width range, it's giving us the depth, it's giving us the height. We can expose all of that stuff the same way we were exposing it before. Okay. So we'll kind of keep this. I'm going to copy this again. I'll turn the preview off there. Save that. All right, let's see what it did for us here in this example. So I'm going to copy the code. I'm just going to replace all of this code with my new code and press OK. All right. So it is randomly placing our boxes. So tower generator, it's randomly generating X from a bounding box. Where's our bounding box coming from? So a bounding box, it's just defining a box. Okay. Tower, it's generating our tower. So this will probably, if we up these values, let's say 10 to 50, let's go to 100. Maybe this is 200. Okay, so I'm just updating our width intervals here. All right, so cool. Now this is a random cluster of boxes here. So one thing I might want to do is give this a seed. I'm going to right click this. I'm going to type hint this and just go to integer as our seed. And I could go ahead and just say random. So under inputs, seed, and give our seed here. I'm going to press OK. That's going to randomly. So now this is going to be controlled as a seed. So if I were to change this, any other input, it's going to maintain itself at our seed. Cool. The chat is here. Here's the Dropbox. Okay. So how can you check if it's actually using the seed or just regenerating it based on the movement in the Grasshopper script? Way to check for that is, let's say you have the script open, and let's say you put random.seed and put your seed, and your seed is here. So that's you don't know, like you change the value and like, well, I don't know if the seed is working. There's two ways you can check. One is you can recompute the solver. That might not be ideal. You know, if you have a lot of other stuff in the script, that might be slower to calculate, but if all you have is this, recomputing the solver, if you recompute the solver, nothing will happen. Like this one, I didn't put a seed in. So let's just look at this box. I recompute the solver. Or did I put a seed? No. Okay. Well, scratch that. Recomputing the solver is not working. But if you take this input and you replug it in each time, like it's the same value, and I plug in X, or I just arbitrarily plug in a value to y. There's nothing attached to y. So if I change that, if the seed is not set, then this value is going to be, it's going to change it every time. So the same here, I have a seed. If I put something, a slider into y, and I change that, if nothing happens in my script, so let me turn that one on. Okay, I made it bigger. If nothing happens here when you change this slider, you can tell your seed is working because it's not regenerating from the code each time. Okay. So if we look at this and we see what it's generating, base plane is base point with the vector z axis. Okay. And then maybe what we want to do is we don't want the component. What if we want to actually just generate our planes themselves, and we want to generate our boxes from a list of random input planes? So we can ask that in ChatGPT. So I can say something like, thank you. Could you modify the script so that it generates the boxes from an input that is a list of, and I'm going to say input planes in parentheses, because then it will make our input that we want as input planes. So instead of input points, instead of the base point, generates the boxes. So basically what I'm saying is I want to generate a bunch of planes, and I want to generate the boxes based on the input planes. So I'm going to try that. Okay. So this one, it's hard to tell without like looking at your code exactly. I mean, one thing that you could try doing is just ask, like, following up with ChatGPT to get your code to diagnose that. I mean, it sounds like what's happening is it's getting a point when it expects a box. But again, it's hard to tell without looking at what the code is. But I'm saving this as we go along, and then I have you should have a link to the chat if you wanted to follow along in what's happening here. I hope that helps. Okay. All right, so I'm going to take this. I'm going to copy that code. So we've got several iterations of this. I'll turn off the old one. Okay, so box. So what I'm hoping that this did, based on my question, was allow us to give it input planes. So I'm going to copy this code. I'm going to replace all of this here. I do have to make the random seed again. That's pretty easy. I'll just do random.seed. Sometimes we got to do this a lot. Okay, so random.seed, seed is an input. Just make sure you don't forget when you copy this in. I'm going to hit OK. And I did expect an error, and it's because we don't actually have any input planes. So what I'm going to do is I'm going to populate 3D here, which it asks for a region, which is a box, asks for a number, so that's a count, a seed, additional points. Let's just set the number right now to something like 25. Do that. I could actually use one of our previous components. So if this was one of our random boxes. I'm just going to take this random box generator that we made before. So I'm using the one up here. I'm just going to give it back to 0. Put it at 0. Make sure we turn this one off. Okay, I'm going to move that to the side here. I want this to be a little bit smaller. I don't know, just play with the values here. Play with the values. Output is a box. This is a B-rep. It doesn't matter. I'll cast this here to the region. It knows it's a box. Okay. So I'm going to delete this slider. What this is asking for is input planes. So I'm going to hashtag input planes out, because what I really want, if I click on this, I'm going to copy that. I'm going to set input planes here as an input. And actually, here's where we need to go from list to item access. We're switching over to list access. So this little bracket here in Python, that indicates that we're actually dealing with a list, similar to kind of lists in Grasshopper. You know, it's not a data tree. It's just kind of a flat list. So I'm going to change this to list access. And I'm going to give it a type hint and call this plain. So just make sure it's list access and plain. And I'm going to just give this XY planes here. Okay, let's see. Okay, cool. But it is not. It is because the number of boxes equals 10. So I could ask ChatGPT to modify this for me. However, I've already made some modifications. So instead of the number of boxes equaling 10, I could just manually do this. I can say length input underscore planes. I think that's what you do. Test. Okay. Hmm. 25 boxes, 25 planes. Almost there. Does not appear that our boxes are actually being created on our input planes. Oh, interesting. It's because it's choosing a random input plane. I don't necessarily want it to do that. So again, it's where we could ask ChatGPT to modify it for us, or we can be bold and go in here and just modify it ourselves. So I think what we can do is we can just say, instead of random.choice for input planes, what I really want it to do is I just want to get input planes. Input planes is a list. So what I need to do is I need to access. So it's saying for I in range, then the number of boxes. I'm going to say I, so it's whatever plane is in the order of my list, because I just wanted to have a box at each one of these planes. So in this case, I'm going to say base plane equals input planes I, and I'm going to test that. And now all of our boxes are being created and generated at each of these base planes. That's exactly what I wanted to do. Okay. Very good. Random box. Okay, I'm going to call this random box tower. Good. Oops. Good. Okay, that's our good one. We're not done modifying it yet. So right now we have input planes. So we're using one of our previous random boxes to generate. I can add more to create it more box-like. But really what I want to do is I want to expose some of these parameters. So our random.seed, our input planes, we just took care of that. So I want to do the same thing with the width, the depth, and the height. So I'm going to go ahead and give us an X, a Y, and a Z, width, depth, and height. And then we can go ahead and the same way that we did our intervals here, I can just copy this stuff from here. Hit OK on that. So I'm going to go ahead and save my file here. Okay, I'll resend the link. Sorry, guys. I thought it updated, but maybe it doesn't. Okay, copy link. Here we go. Okay, I hope that helps. Okay, so back to Python. I'm just gonna shorten this a little bit. Drag this over a little bit here. So width range, I'm gonna copy that, put this here. Depth range, you can double click, Control C, Control V instead of Y. Height range, Control C, Control V instead of C. So these are just the domains that I had copied earlier. I'm going to plug these into each one of these. And according to good practice, I'm going to do type hint and change this to interval on all of these. Interval, type hint, interval. So go ahead and do that on all of those. And then the last thing I need to do is I need to just make sure I comment this stuff out so that it doesn't overwrite in the code. And I'll hit OK. And now this is my new kind of tower form from my base planes. So maybe my height, I want it to be taller. And I don't know, it can kind of change the width and depth and play around with it. So we can change the seed of our random generator. That's going to generate random boxes at each stage here. So I'm going to go ahead and save this. We can also set a seed here for our populate. So if we wanted to change the locations of our box, we can do that here. And we can also change the seed of our original box that's populating it. So we have 3 different seed values that we could mess around with. Yeah. So the cool thing is, like, we're basically just using this to generate points and then create planes from those points. So this is really just a way for us to get points to generate boxes from this, but it's not the only way to do it. We could generate planes kind of in any way we want. So like, what if we wanted to start with a more organic form? So something that we could do is in the dependencies that I shared in the folder, like one of the things like that we'll play with here is Dendro. So what Dendro allows us to do is it allows us to kind of quickly create voxelized approximation volumes for really a variety of geometry types. So you can use this to create wrappings around curve geometry. You can thicken curves, you can thicken points. So there's a lot of different kind of applications for it. Like in one way, you can use it in a really refined way to get watertight meshes over for 3D printing if you have a bunch of like disparate geometry. What I like to use it for is generating more goopy organic types of shapes. So that's what I'm going to use it for now. So I'm going to go ahead and save this out. Let's just say this is our random box tower that we're going to be using. And maybe, let's see. Yeah, we can just work in this file. Okay, so if I do rendered preview, all my other boxes are going to show up. So let's go ahead and disable those. Okay. All right, so one of the things that I might want to do is I might want to make, since this is called intelligent generations, I think maybe let's not do anything anything where we model in Rhino. So basically what I want to do is I want to take I just want to create a blobby form. So I want to make some blobby form like this and populate it with points and then make some boxes on that. So it's going to have some like, it's going to kind of approximately follow my blobby form, but it's going to populate it with orthogonal geometry. Oops. Okay, get out of that. So I can use this same setup here. So maybe let's just take this stuff and I'm going to copy Control C, Control V one more time. So, and then I'll go ahead and disable that. Okay, so that's all off. So we're only working with this new one that I copied down here. Okay, so this is the old one, this is the new one. Okay. So the first thing is I'm going to disconnect this for a second. So this is not hooked up to anything, no output. I'm going to change this down and I'm going to scooch this over a little bit so we have some room to work here. All right. So my plane, I'll just get rid of that for now. So I have these points. So I'm using our random box generator. We're going to generate some points. I don't know, maybe I want it to be a little taller, wider, I don't know. Let's say it's something like that. I have fewer points, really don't want that many for this. Okay, so I want to basically convert these points into a volume mesh. So I'm going to use Dendro here to do points to volume. Okay, so what that's going to ask for is a set of points. I'm going to plug my points in here. And it's going to ask for a point radius, and it's going to ask for some settings. So settings, I need to do create settings. And then the radius, I can just give it some big value right now. Maybe, I don't know. What's the distance if I go to a top view? 17, okay. All right, just some floating point values. So plug that in. I'll copy this, plug that into settings and plug my settings in. Okay, so I'm using the same value for my voxel size. This other stuff, bandwidth, ISO value, we don't need to mess around with that for this purposes of this. That stuff, you could get into if you really wanted to play around with it. I'm not going to touch it. I'm just looking at settings here and I'm looking at my radius. So settings, because that's the same value, it says radius must be at least 33% larger than voxel size. This will compute, but no volume will be created. All right, so we can very easily change this by giving this radius a multiplier. So I can say, whatever my point radius is, if it needs to be 33% larger, that means that this needs to be maxed out to 60.66. So I'm going to do 0 ... .66. Nope, that did not work as I intended. 0 ... .66. Okay, so now it's a slider from 0 to 0.66. I'm going to plug that into B. So now it's always going to be multiplying this by 66%. Plug that into settings, and now I have this volume from the points. Okay. So I could refine this a little more. This could be a little more spherical if I change the multiplier down. You don't have to keep it at 0.66. It's just 0.66 happens to be the max value. In this case, that's kind of ugly. So I'm going to go something more like more spherical and blobby. All right, so this is giving us a volume. Volume of points, and if I change the number of points, it's going to create these sort of like voxel radius things around my points, and really just kind of play around. I don't want that many, and I might want my radius to be a little larger. It doesn't have to be super refined. So right now, this output is a Dendro volume. There's a couple things I could do. I could smooth my volume. You can kind of see I don't have mesh. Oh, it doesn't show mesh wires anyway. Okay, smoothing the volume, that works very similarly to Grasshopper's smooth component. Width, it has types, which are Gaussian, Laplacian, mean, median. I could get a slider 0.3 of 0 to 3. I tend to think that Laplacian works the best for most of the things that I do. I tend to keep it on 1 here. You can also change the number of smoothing iterations. So let's say I want it to change that to 3. Okay. Yeah, whatever. Okay, so there is a component to convert mesh to volume. I don't know. Call me a barbarian, but I just plug this into a mesh explicitly. I find that it tends to be faster to run that way. Yeah, this is the output mesh. So you can toggle mesh wires on and off by hitting Control-M on your keyboard. I do this because in my experience, this is a very simple and like easy to make volume. It's very fast because you're not dealing with a lot of points here. The more points you have, the slower it gets. So whenever I've done mesh to volume, you got to give it settings. Usually I just give it these same settings. It takes longer to compute, even though oh, that's because that's the wrong component. Sorry, volume to mesh is the correct component. Anyway, and it even changes the output a little bit from what this mesh is. Probably because we're giving it some smoothing. Anyway, this works just fine. I tend to prefer doing it this way. And just because, why not? We can also give this a smooth mesh component where you can find under the mesh tab and smooth mesh. So I'll plug in that. You can change the smoothing strength. This is really doing the same thing as that. I don't know. In my experience, I like to double down on the smoothness here. We can kind of copy and paste this later. So iterations, you can also copy a slider and give it more iterations. We can keep it at 1. Okay, so this is going to be our mesh. And I'm going to go ahead and turn that off. So now instead of, and maybe I want this thing to be much larger. I don't know. Yeah, it's kind of cool. You see it's separating the larger we get. Starts to separate those values out. So let's go ahead and up our radius. We have this blobby thing. Maybe I have 5 of these. Okay. So now we have our random tower box script. I'm going to turn the preview on for that. Another component that's deals with randomly populating points. We can use the populate geometry component here, and I can populate this mesh with random points. I can also give it a seed value. Maybe I'll give it 200, and I can give it a number of points. So I don't know. Let's maybe get it even more points. So 120. So at each one of these points, I can convert that to an XY plane, same way we did before. I mean, really all I'm doing here is I'm showing us a couple other ways that we can think about kind of populating this kind of stuff. So right now we're going from a more like organic blobby thing. You could think of even this in the same way as like you could model something in Rhino and then input this and populate it. But right now what we're doing is we're just generating everything. So no manual modeling. Okay, so we will plug this in XY plane into our input planes here and now get our boxes and more or less conforming to the shape of our mesh. So I'll go ahead and save this so you have access to that. Yeah, very much. Okay, only the old content. Sorry, not sure why the link is not working for new content. I think this should. I think this is everything. Anyway, I hope that works. Maybe try that. Yeah, I'd love to see some experiments with biomorpher, David, if you wanted to dive into that. Cool. Okay. Sorry. Not sure why. Anyway, this should work here though if you open up this file. I'm saving this periodically in the random box live example. Cool. All right, so saving again. All right, so we have this random box tower thing generated from our blobby form. We can kind of change the seed values and it'll change our box configuration because it changes the form. And then we can do the same thing for our box itself. So if we want it to like kind of conform to that shape, maybe that's a shape that we like. And we just want to see different box configurations on it. So maybe we want this to be a little bit wider. Maybe we want this to be, I don't know, wider in that direction, or maybe that's too much. We could even change this to go taller. Maybe we want that to be max of 500 instead. Go very tall. And then we can change it around. Yeah, you can play with the radius, like all of this is going to change. But that shouldn't change. Okay. All right, cool. Maybe I'll add a couple extra, change that around. So yeah, if we wanted these to be like even smaller, Like maybe we don't even want, maybe we wanted to see some of the organic shape and we wanted to see some of these boxes as thinner pieces coming off of here. We could do that too. So we could start kind of hybridizing some of this stuff. Okay, but we'll get to that. All right, so now let's say we did kind of our organic form here with our mesh, and we populated this with orthogonal random geometry. So we've got our output as boxes here. Just going to go ahead and turn that off. Let's say we want to use Dendro to smooth this out. We can do that. So in Dendro, what we did before is we did points to volume. Well, we can also do the same thing with mesh to volume. So one thing we need to do is these are boxes. They're more kind of implicitly close to B-reps, but you know, box is its own geometry type in terms of Rhino geometry. So what we can do here is convert this to a mesh. I'm going to use simple mesh because it's a box, because it's defined as simple faces, four-sided faces. We can use the simple mesh because it'll make as simplified as possible of a mesh from each of these as we can. Okay. So I've turned this into a mesh. I'm just going to use the mesh join. I'm going to join these. So it's not necessarily, it's not Booleaning them together. Instead, these are all disjointed mesh pieces. I found that when I do this, it tends to make this mesh to volume go a little bit faster. So mesh to volume is looking for a base mesh and it's looking for settings. So I'm going to plug my base mesh in here. I'm going to grab the create settings component again. Since we don't have a radius, all we're looking at is a voxel size, so I can give this a single slider. I don't know, maybe 35.5. Always add some extra zeros just to give some more fun to it. Okay. So settings, that goes into S. And then we get a Dendro volume from these settings. And I think the volume is a mesh. It works the same way as what happened with the meshes. So because Dendro tends to be faster, than if I were to just do a mesh union. Okay, this is going to take 1.9 seconds to give us a mesh union in Grasshopper. The volume union in Dendro, because it's using an OpenVDB library to be doing this, much faster, only 21 milliseconds. So it's an order of magnitude faster to do it this way. I'm going to take some of this stuff down here. So these are my volumes. And all I'm going to take is where I'm smoothing these meshes here. And I'm going to copy that, paste it. I'm just going to drag this stuff over here. So I'm just taking my smooth volume and smooth mesh. Go ahead and save. And instead of here, I'm going to take this volume and plug it into smooth volume. Oh, and it's extremely smooth. It's just a blop now. And part of that is because the higher this value is, the fewer faces are going to be on the mesh. So if I hit my mesh faces, and the lower that value, the more faces and the closer it is going to be to your geometry. And I'll just copy this preview so we can look at this. A little easier to see. Okay. So the lower we go here, the closer we're going to be. And always be careful when dragging sliders. Okay. So now this thing is more box-like, but it has kind of round filleted corners because we have a pretty low V setting. The smoothing on here kind of takes, now it's taking over a second for that. So you can see it it'll start to get slow after a while. Maybe I'll limit this. I'll just say 1 for now. And I don't need this to go all the way up to 100, so maybe I'll say 30. And I'll put that at 4. Okay. So the more goopy, the lower it is, or the higher it is, the more goopy it is, until you kind of find something that feels right to you. Cool. All right, so I'm saving that. So up until this point, we've used ChatGPT to generate random boxes in a couple different ways. Now we've kind of made ourselves a random box tower generator. In a way, maybe it's less of a tower, but it does, because we have these input planes, we can think of this as really just a component that will generate random boxes on any set of planes that we give it. So maybe that's sort of the power of what we've done here in creating this component. Cool. I think this might be a good time to take a break. What do you think, Mike? You're still on. All right. Let's do maybe a 10, 15-minute break. And I will see you back. Let's just say 1:30. All right. See everyone back at 1:30. All right, we're back. And thank you. I'm glad you enjoy it. All right. Got this saved. Awesome. Okay, I think now, let me just enable that and preview that on for a second. Don't need that anymore. Save that. I think this is a good chance for us to get into stable diffusion here. So we're going to look quickly at stable diffusion. It is very similar to MidJourney in that it is text to generate imagery from. However, what it differs is it's much more, because it's an open source model, you download it as a model in Python code. It's a little bit more of a sandbox, I would say, than MidJourney, where MidJourney is much more of a refined product that's trying to get you good results, right, with very little effort, whereas stable diffusion requires a lot of, I would say, testing and playing around with. So really what we're going to do with stable diffusion, we're kind of going to look at this, in a very basic way today. A lot of people out there can do super advanced stuff with it. I think we'll just kind of dive in and look at it. Like, essentially the goal of this, like if we looked at MidJourney, we start with, that's a way for us to rapidly sketch out ideas of, some kind of concepts that we might want to play around with. Then we're using ChatGPT to generate Python code to can maybe mimic some of the, ideas that are, and not necessarily mimic, but just, create form from some of these ideas that, we're working with in MidJourney. So we're asking it for Python code to, help us aid in like computational form making. And we can look at things like orthogonally, we can look at boxy geometry, and then what we can take and use stable diffusion for is kind of further refining some of our creative process here. So, now that we've created some of these forms, like it's not really articulated, well, maybe we can actually use let's say, stable diffusion to kind of like render some articulations on this and just see what kinds of things we can get. So if you have stable diffusion, you should have it installed hopefully by now. I mean, if not, just kind of watch following along. So stable diffusion you access in a web browser. So when you install it, it should be probably located in your user folder. So I have it under users, my name, and my name's spelled wrong, and stable diffusion web UI. Oops. Okay, so in this folder here, if you have it installed like this, you just go, track to stable diffusion web UI, and the file that you need to click on is webui.bat. So it's a .bat file. If I click on that, it'll give you this screen. It'll give you the command prompt, and it will open this up in a virtual environment. So just to let you know, I have my limitation here is I have the lowest amount of possible VRAM to actually run stable diffusion. So most of the stuff that I make with it is pretty low res and not like super refined. And that's mostly just a hardware limitation for me. So bear with that when you're making. If you have a more powerful machine with more VRAM, you could possibly get better results and quicker than I can. So I'm going to probably keep some of this stuff at lower resolution. Okay, so this is what happens. It loads the web UI. What you're looking for here is running on local URL. You're looking for this IP address here. So I'm going to take that and I'm going to copy that. I already have it up here, but let's say I didn't, and I just open a new tab. I can click this and paste the Stable Diffusion IP here, and it will take me to the Stable Diffusion web UI. All right, so this is Stable Diffusion. Similar to MidJourney, but it kind of exposes some of the variables. It starts with, you have sampling methods. I'm not even going to play with that. Negative prompts, it's prompts. I'm not going to mess with that right now. Sampling steps, 20. This is just kind of like the number of samples that it'll do in its diffusion process. It gives you options for resolution. This CFG scale really just is weighted towards it's kind of like prompt weighting, how close it is to the text or how far away it is. The default of 7 tends to be pretty balanced. So unlike MidJourney with Stable Diffusion, like other indicators that, I think you typically saw in maybe prompts in the past, they're pretty useful here. I'm using the 1.5 model. So let's just say I want a cyberpunk city scene with randomized box buildings. I don't know. Let's say I want this to be like Tokyo. Maybe I'll give it another cyberpunk here. Blade Runner. Maybe we want it to look kind of like Blade Runner. And then we could do stuff like 8K, 4K, I don't know, something like ArtStation. Seems to be a popular thing to put on here. Negative prompts, it would be something like things that you don't want in your prompt. So I could say something like low quality, low resolution, things of that nature. I don't want anything that's looks bad, things like that. Maybe we want like dystopian or utopian. I don't know. Let's just keep it at this. So you could do a batch count. So the batch count is going to give you, that's the number of images it's going to generate. Let's just stick for one for right now. And I'm going to go ahead and generate this. All right, so I kept it at the default resolution, 512 by 512. So let's see what it gives us. Okay, so it gives us a pretty nice image here of a cyberpunk city scene. I could generate again. Let's say I do this again. It's going to generate another version of this. Okay, that one, it's pretty nice. You can, either I could keep generating it, or I could say maybe I want my batch count to be 4. So let's keep it similar to MidJourney. So if I hit generate on 4 of these, now it's going to generate through 4 different images and show the output. It'll kind of give us all of them. Okay, so it'll give us an image like this. So depending on how many batch counts you have, it will adjust accordingly. Okay, so these are pretty nice. So let's say I like this one, and maybe I want to, riff on this one and image to image. So one thing that's cool is, we have our prompt, we have our text prompt, and we can also do an image prompt that also uses a text prompt. Okay. I mean, the why and the when, it really just depends, honestly. I would say it's an either or like, I think one thing that I was maybe alluding to earlier is I tend to use MidJourney as looking at ideas quickly. Like you could also use Stable Diffusion for that. I mean, it works the same way in that sense. I just happen to like the output of MidJourney, so I think in a way it kind of depends. What I tend to do is, well, MidJourney for just like off the cuff idea generation, and what I typically use Stable Diffusion for in my process is like using it with ControlNet. So I tend to not use it for this purpose of just like quickly generating things, only because I think the output of MidJourney, in my opinion, tends to be much like better. But that's also part of my VRAM limitation for Stable Diffusion. So I think maybe if I had a better GPU, you know, I might be a little more, it might be more desirable for me to play around with Stable Diffusion in that way. So for me, it's like MidJourney gets me cool ideas quickly. Stable Diffusion, I tend to use like, I think what we're going to do here is we're going to really use this as kind of a, almost like, it's not quite the same, but it's almost using it like a rendering engine. Kind of like we're going to be using ControlNet to kind of take like a screenshot of our form and use that we did in, we're doing in Rhino, and kind of maybe overlaying some of this stuff on top of it. So I hope that kind of answers your question here. Awesome. No problem. Okay. The bare minimum is 8 gigabytes of VRAM. So I have a 2070 RTX graphics card back from 2019. So it meets the bare minimum specs. No problem. Okay. So by the way, if you want to access your folder, you can hit the folder here. It will pop up and go to today's date. And all of our images that we create for the day, it's going to create here. I think that's labeling them with the seed value, which that might be important for us in a second. So I'm going to go ahead and send this to image. Okay, so I'm going to keep the text prompt. So image to image, it's the same thing as our first page here with text to image. But image to image, we're using an image as a reference. So I'm going to create a new image, basically using this image and our text prompt as a basis. So I'm going to keep the sampling steps at 20, but maybe, I don't know, let me, what's that times 2? 1024. Okay, 1024. I'm just going to double up our resolution. I'm going to keep everything else the same, and I'm going to go ahead and hit generate on this and see what comes out for us. All right. Well, that's pretty cool. It's pretty nice. It's like a little bit higher resolution. You can kind of make out text. It really doesn't look anything like this. I mean, it's qualitatively very similar, but which I guess that's what we're going for with the image to image and then the text prompt. But one thing that we could do is I I could keep the image and I could keep the text. I could go back to our text to image, and now that I'm clicking on this one, well, it tells us what the seed is here. So I could actually take this and I could copy, Control C, go over here to text to image, and the seed now is -1. That means we're going to get a randomized seed every single time. Well, I want the seed to not be randomized. I'm going to take the seed from this image. Oh, I had that. I scrolled. Whoops. 34. Okay, I'm going to take the seed. Make sure you don't scroll up, otherwise it'll screw up your seed value. All right, click off. So don't do that. Don't do what I did. Okay, so that's the seed value. And now I'm going to generate this using the same seed. And I hope I don't run out of memory on this. Should be fine. A lot of stable diffusion is sitting and waiting. Tends to go a little faster though if I'm not screen sharing on Zoom. All right. Well, that is pretty cool. It is a little bit closer to our image here, but it's still pretty different. We're using the same seed. So using that seed, it should generate this image every time we hit generate, because we're using that seed. But what we could do is we could now use ControlNet. So ControlNet here, when installed as an extension, so automatically this image here is in our ControlNet in image to image since we sent it over. Okay. So what ControlNet does is there's different models, like all of these things do different things. If you look at the documentation for ControlNet, it does a pretty good job of explaining, you know, all of this stuff. So part of this is about like refining what our settings are. What we're going to want to do here is I actually only have 2 models installed. I have Canny and Depth. So those are the only ones I'm going to look at. They just take up a lot of file space, so I didn't bother installing the other ones for this workshop. But let's we're going to be looking at Canny and Depth, and you can toggle between them. So you could do all, and you could automatic, like you could select manually Canny, and then you have to match it with ControlNet Canny model. Well, an easier way to do that is just to toggle it to Canny or toggle it to Depth. So it'll give you the right thing that you need. So Canny, what that's going to do is it's actually going to draw outlines. I hit the allow preview. So first of all, I have to enable ControlNet. So right now it's not enabled. So if I hit the ControlNet dropdown and enable it, that's going to be using ControlNet here. Okay. So the way that I did it was when I created the image text to image, and when I did text to image, it automatically uploaded it to ControlNet. However, if you wanted to manually do that, you could just take this image and you can drag it here. So I could just drag that on and it'll do the same thing. Okay. So Canny, it gives you options for control weight. Like this is something when we're looking at our screenshot, we'll probably play around with. Pre-processor resolution. This is kind of, usually don't mess with that, but you can kind of match your resolution. I'm just matching the resolution of the image here. This stuff, we don't really need to play with this right now. So let's just keep the defaults and see what this does. So what Canny is going to do is it's going to draw outlines around our image. Say allow preview. This interface changed recently, so it used to just generate the ControlNet image. Anyway, well, we'll see it when we generate this image. Okay, so I have ControlNet enabled. That's the important thing. Allow preview. And now I'm going to go ahead and generate with ControlNet on using the Canny model. And we'll see what Canny means once this thing generates. Okay. Let that go. Sort of overestimates it at first. All right. So now that we have ControlNet enabled, we can see that this is much closer to our original image. We've also doubled our resolution, so it's going to be at a higher quality. You can see it's sort of like smoothed out our image a little bit, but it is basically, you know, the same image with more pixel resolution. So ControlNet Canny, basically what it was trying to attempt, or what it attempted to do, was get outlines of the major figures and shapes in our scene. And then it's filling in the gaps around from that. So it is using this as a reference. You can play around with the settings that kind of toggle our processor resolution. Like if you wanted this to be closer kind of line weights to what, that's something that you can play around with. I'm not going to mess with it right now. So that's Canny. It's finding outlines of our major shapes and then making our image based off of that. Okay, so let's try the depth. So depth is our other model. I'm not going to change any of these settings. Let's just run it from the depth model and generate a new image. So the different models, they do like slightly different things. Like I said before, Stable Diffusion is much more of a sandbox. It's something that you really have to play around with and refine your settings. And, you know, I think it's kind of a craft in and of itself to get good settings out of Stable Diffusion. But, you know, that's something, you know, we're kind of just using it now as a tool to help us kind of render ideas off of our form that we've created. All right, so we can already see depth is giving us a little bit of a different result, because it's less focused on outlines and more focused on like a depth map of what our image is. So still very similar to our original. We can tell it's higher resolution, like a little more smoothed out. And that's because the depth map it creates, like this is what it looks like. So it's basically trying to conform the image to this depth map here. Okay. So we could play around with some of these to kind of refine the depth that it's creating. Like we can say my prompt is more important, or ControlNet is more important, or we can keep it balanced, and that's going to, you know, balance both equally, or attempt to do that. Okay. So let's try giving this a different image. So right now, text to image is this. Maybe we don't actually care about the seed anymore. So I'm going to turn that back to -1. And I'm going to replace this image with something else. So let's see. Maybe let's use one of these MidJourney images. Okay. How about this one? So I'm going to use the MidJourney example 1, and I'm going to input that. I'm going to drag that here. So this is going to be the input image. ControlNet. Okay, so it automatically changed our ControlNet here. And let's keep the cyberpunk city scene randomized box. So we'll keep that and we'll use this image as kind of a mood image and see what that gives us. I'll just change, I think this is 4:5 resolution. So maybe 1000 by 800. Yeah, okay. I'll change that resolution 800, 1000. Okay, so let's try it out with this. And while that thinks, I'm going to set up this Grasshopper script for a second. Okay. Grasshopper, I'm just going to get the brep edges coming out of here. Okay, I'll do that just because that's best practices. I gave everyone human for the sole purpose that we can visualize lines. So I'm going to get the interior edges here, plug those in, get a color swatch, turn that to black, and then we can change the thickness of our edges. Okay. And I'm going to plug simple mesh in here so we don't see the edges. Okay. Let's put that in a rendered view. Maybe I play around with the seed. All right, kind of like that one. Okay. This one is taking a little while. Alrighty. Okay, while that thinks, let's do a screenshot of this tower. I don't know, something like, yeah, something like that. Just kind of pick a view. It doesn't really matter. Let me do snipping tool. I'm just gonna grab something. It'll probably stretch this out, but let me just save this snip to file share in images. I'm gonna say model screenshot example 1. Okay. I'm gonna save that. This one's taking forever. Might not even look good. Yeah, this is sort of when you have lower amounts of VRAM, this tends to take a little longer to do some of this stuff. Yeah, you can plug it into the image sampler. I've played around with that a little bit. I'm not gonna do that today, but that is something that you can do. So you could take like you could say, I want some kind of pattern or texture out of MidJourney, and then ask it. I mean, the basic way is to use the image sampler and create some kind of mesh. You know, maybe more advanced, you could like trace the outline curves and then try to mesh that. That could be an interesting way to deal with it. I don't know. It's something that I haven't played around enough of, but like the most basic sense, yeah, use the image sampler to do that. Awesome. Oops. Okay. Three minutes. Well, I could kill it and do this at a lower resolution. Or wait for it. All right, I'm gonna kill it. We don't have all day, as much as I would like to see what this looks like. Okay. Oh, there it goes. Okay, well, it finished anyway. So yeah, I mean, it's okay, but what's cool about it is it's now taken something we've given it as an image. I mean, this image is a little more refined, but it's remixed it a little bit with ControlNet and the depth model here. So that's kind of the depth map that it created. And it's made it a little more cyberpunk, where this, you know, I mean, this is kind of cyberpunk in it itself, but it's not quite, you know, the same, you know, Tokyo Blade Runner type of stuff. So it's kind of adding some of that stuff to the scene. All right, I'm gonna keep the rest of these at 400 by 500. So, okay. I think what we can also do is we can use this image as a reference, but we can also, now I've saved this screenshot. We can use this as the ControlNet model. And maybe for this, I'll do Canny because it'll find the outlines. So this image could be used as a reference image. Our text prompt could be the same text prompt. But really what we're doing is we're taking a screenshot from our model to kind of interpolate some of this stuff onto this model screenshot. And it, frankly, at 400 by 500, it's probably not going to look super great. I think, that kind of is what it is right now. But yeah, let's test it out. So I'm going to try to see, I put this at 400 and 500. Let's generate. All right. So that's kind of cool. So it's taking, some of our text prompt. This is our lines. I think part of it is I just took a screenshot with snipping tool. That's why it is looking a little bit jagged on the edges, edge definitions. You can see now, basically this is an arbitrary resolution that I took the screenshot. What it's doing is it's basically just scaling it. It's like smushing it to fit within the resolution of our input, which is a 4:5 resolution. So, but it's basically rendering stuff. Like we just took a model screenshot and now we're using, stable diffusion to get some results. And we're combining it with just the image to image. So if we wanted to do text to image here, we could use ControlNet this way and not actually have kind of an example image. So ControlNet, if we're just using ControlNet from the text to image prompt, maybe that's all we need. So I could do the same thing where I kind of did this backwards, but yeah, bear with me. We could take our model for ControlNet. I enable ControlNet. And, let me use the Canny model for this. And let's just use the same prompt that we've been working with here. And let's generate a batch of 4 here. So I'm going to just do 400 by, 400 by 500. Okay. So I'm not going to change anything. Let's generate some of these. And just in general, changing the sampling steps also helps us a little bit when, like if you upped the count on this, it'll make your imagery a little bit, it could make it more refined. I'm not doing it because it'll take longer to generate. Okay, so let's see what this gave us. Yeah, it gave us some cyberpunky looking stuff on top of our box model. Now, because it's like relatively low resolution, it's not like going to give us the best results necessarily, but it's giving us some kind of nice mood definitions and some interesting kind of articulations to our massing geometry. So we're really just kind of like now creating little sketch renders from our geometry. So I think you kind of get the idea now. What we're doing here is like MidJourney, sketching ideas, going to ChatGPT with Grasshopper, making generative forms, and then taking these into Stable Diffusion to kind of generate some more refined imagery from, as opposed to just screenshots. So it's kind of like rendering on top of some of these kind of models. Okay, so other things that we can do, like one thing that I found is if I play down the control weight, maybe something like, I don't know, 0.65. So what the control weight is, it's basically how closely it's going to conform to our geometry. Sometimes I find I get more interesting results, like let's see, in this example here, this is done the exact same way that we're doing now. I took a screenshot, input it into Stable Diffusion, and then I actually was using a lower control weight to get that image from a similar type of screenshot here. So let's see what this gives us. It might add a little bit, it might add some more features. Maybe not though, because of the low resolution, but let's see what this gives us. All right. Okay, so you know, it has a little bit more freedom in its variation of form. By lowering the weight there, you can see it's not exactly conforming to to the original form that we were working with. It's kind of moving it off, but it's basically giving it the same language of the boxes and the same kind of like formal definition. So it's like loosely working with us in our screenshot, but it's got a little bit more creative variation in its output. All right, so yeah, that's a pretty low res one. I mean, we could take a higher res screenshot of this and maybe that helps us. So we do view capture to file. Yeah, maybe let's do a custom. Okay, center it. I'll just keep the scale at 1. Okay, so 800 to 1,000, and I'll save this in the share and the images, and let's do a PNG model screenshot example 2. Save that. This may or may not be better. Typically, like if you save it at a higher resolution and then give it to ControlNet, it probably understands the definition a little better. So let's just give this a try. Okay, I'm just going to generate one of these. Yeah, well, a little bit more texture probably. Yeah, and you could make the resolution of your image, like when you take the screenshot, like you can change the scale of your resolution so that it's even more refined. I think maybe we can even we can up this. If I up this to 800, it's going to help us. We'll try that. Okay, that helped us a lot. So preprocessor resolution, that helps us. So maybe let's kind of balance this. Let's do 1000 and maybe let's up this one. I don't know. Let's do 0.85. And right now I'm playing around tweaking the settings. Part of this is, I think, very much experimenting with what we're doing here. All right, so that's very close to the screenshot, and it's kind of giving us some, I don't know, pretty nice results. There's no reason I have not used those. This is just kind of the way that I was doing it in the first place. I kind of liked having the open source model web UI. Yeah. Honestly, with all of this stuff, there's like new tools coming out every day. So, part of it, it's good to stay on top of it as much as you can, but at the same time, certain things you just might gravitate towards. So there's not a good reason. I just haven't really dove into those ones. Cool. Okay, so using it, I do use it for fun. For like this kind of stuff is not what I would factor into my professional work. This is kind of like my own personal creative process, like for personal work. However, professionally, that's like a major debate. Like right now, I'm on a panel of like, there's kind of a committee of architecture firms that kind of talk about these issues. Like we've got surveys going out to poll different firms, how they're using AI, like what kind of like privacy concerns. I think like right now, everyone is sort of asking these questions. I'd say the bottom line is if you've got proprietary data or anything like that, do not upload it to ChatGPT. I mean, things that we're doing like in the professional sphere is much more, it's much more sensitive. So, we might tap into like the API. So we'll get like an API of, GPT-4 or something like that, and kind of train our own models or our own things. Is like something that I always try to tell people is don't put sensitive information onto the web in ChatGPT, because what that will do is it will blend it into the overall model of like the overall training data that ChatGPT uses. So if you put sensitive information there, it's going to like, anyone else could access that theoretically by asking a question about you or asking a question about whatever company you work for, if you've tied that information to your company. So, I mean, I think there is a lot of privacy and data concerns when it comes to this. I mean, one of the things that's nice about Stable Diffusion is its open source nature, and all of this stuff exists locally. So I can kind of generate this stuff and it's all local to my machine. It's not being fed back into the model itself. Now, if you can like, if you're more sophisticated and you want to train your own models and you want to access API keys, like that's probably the way to do it when you're dealing with more sensitive information and you're using large language models. I mean, there's different large language models, and there's like a bunch of probably different ones other than the ChatGPT. So I don't know. I think that just depends. Cool. But yeah, I mean, privacy is definitely a hot topic right now. The sampling steps, that's just the number of steps that it's processing. So if I change this, it'll take longer to process, but it's going to like give you a more refined result. So if you want to change the number, you can. Like if I went up to 40, it's gonna, I don't know, it's not necessarily a one-to-one change, but it'll make a little bit more refined. I can do that. I guess I could have done that while I was answering the last question. It'll take a little bit longer generally, but it'll refine the number of steps and typically give you a little bit more detail and a little bit more refinement to the process. Cool. Awesome. Okay, so this is Stable Diffusion ControlNet. So now we're making our fun cyberpunk renderings from our nice cyberpunk-esque 3D model that we've generated. So what's cool is like you could just take different screenshots, you could take different views, you know, whatever. I like that view. And you could throw this in and just generate to your heart's content tons of different renderings. Like I could bump up my batch count. I could change my text prompt, maybe cyberpunk city scene. Maybe I want it to be more utopian. And maybe I want this to have lots of trees. Not really sure what that's going to give me. Maybe I don't want Blade Runner or that cyberpunk. Maybe Tokyo is okay. So I don't know. You could change the prompt around. Maybe dystopian. We don't want that to be on here. So it might contradict the cyberpunk a little bit, but we could see what this gives us. I'm going to change this to, let's say 30. So yeah, I mean, in this process so far, I haven't really changed the prompts much. But you know, one of the things that I've found with using ControlNet with like the screenshots is some things like refined detail. And I think this is also part of a RAM limitation, but some things like, you know, trees, it might not find its way into your model. Like if I didn't have ControlNet enabled. Okay. So still pretty similar kind of aesthetics. There's some attempt at detail. But I will say it took me a lot of playing around with this and a lot of experimentation to get to images like this. And this is not even like nearly as refined as what other people are doing with Stable Diffusion. So I'll just kind of like throw that out as a caveat here. You can get very sophisticated. So like you could take this image and then you could, like if I had the seed, I do somewhere. Actually, no, I don't, because my hard drive crashed. Anyway, I don't have any of my old stuff. So this, you know, hypothetically, if you got to this point, you could take the seed and then you could upscale it and you could refine it even more. Like there's some amazing stuff that people are doing with Stable Diffusion to get refined imagery. I mean, you could even take MidJourney imagery and do the same with that. But, you know, I think for now, like the gist is like, even to get to this point on my computer, like this took a lot of playing around with, a lot of experimentation. So like, I think just keep that in mind when using these kind of AI tools, like some of this stuff really does require a lot of input and a lot of experimenting. Okay, so I'm always interested in getting kind of stuff that's more like this in Grasshopper. I could probably imagine like several ways to do this, writing a Grasshopper script, but maybe in some capacity, I might try to ask ChatGPT to help us with maybe getting some of the like formal qualities of some of this stuff. So, things that we could mess around with. We could mess around with like randomly moving particles to kind of create squiggly lines. We could play with natural systems, like Coral was one of the text prompts to get an image like this. So now we're kind of taking a step back. I've kind of shown you the whole process. So now we're backing up again. We're going to go back to ChatGPT, and instead of using ChatGPT to generate kind of more boxy rectilinear forms, like we're kind of going to build off of that process and think of using ChatGPT to do more like nonlinear stuff and more kind of organic form making. So we're going to look at randomly walking a particle, and we're going to look at creating an L system. So that could go a lot of different ways. So bear with me on here. The L system, we might get mixed results, but that's kind of part of the fun on this. So, and if anything, I've got the scripts saved as backup. So we have some I've already saved some scripts out that, anyone could feel free to open up and play around with. All right, so yeah, let's get some more, I hate to use the word organic, but since that's the kind of word that the signifier we're using for all of this stuff, in a lack of a better term, like more organic types of nonlinear systems coming out of ChatGPT. I'm going to spare us, like one of the things that I've been trying to do is I did get a flocking script to work with ChatGPT. I'm going to spare everyone the process of we'd be here for another like 10 hours trying to figure that one out. So while it is a cool thing to get from ChatGPT, honestly, you probably could write one faster in Python than you could get ChatGPT to make it for you. So let's start a little more simple. Okay. I'm going to go back to Rhino. I'm going to save this one. I can turn off this. Turn back to shaded preview. Let's orient ourselves a little bit here. I'm going to go back here. We have Python. I'm going to delete this. Hit OK. Okay. I'm starting fresh. And I'm going to save this in our main folder here, and I'm going to call this organic form live example. Okay. Amorphous shapes. Yes, that's better. Amorphous shapes. I also like to describe a lot of this stuff as goop. It's goopy. So let's make some goopy stuff. That's a technical term. All right. So back to ChatGPT. I'm going to start a new chat. Let's just say, are you familiar? Or actually, let's just try to get it to like move a particle for us. So can you write me a Python script in Grasshopper 3D? I'll say for Grasshopper 3D. That can move a particle in a direction based on a number of steps. move a particle, input. I'm going to call the particle something like input point. In a direction based on a number of steps, num steps. So you can kind of ask it to define these inputs for you. And that's what I'm doing here. Okay, so good news is it's automatically giving us Rhino geometry. So basically what I asked it to do, I'm going to copy the code. I'm going to just paste that code here and hit OK. All right, so it did do something. But essentially what I'm asking it to do is, let's say I give it a particle, which is a point. Okay, maybe I'll draw it as a point. I'm just asking it to move that in a direction based on a number of steps. So if it's iterative, it'll say, based on one step, move it a distance. So this is distance d, and then move it along a vector at another distance d. So it might just be moving this in a linear way based on a number of steps. So at each step, it's going to move our points. Okay, so let's see what this actually is giving us. Okay, so it's giving us like a proper definition for making kind of a component, like if name equals main. We don't have to get into that, but so its input point is our start point. Direction is, looks like it gave us in the X direction. Number of steps, 5. New point equals move particle, which is our input point direction steps. And then it's just printing the new position. So it looks like what it's doing is it's getting our current point, step vector, it's direction times number of steps, and then it's just moving it times. So it's really just giving us a multiplication. Okay, so let's just say new point. We can just say A equals new point here. And there's our new point. So it's not that spectacular. It's just kind of moving this point in a direction based on the number of steps. So, which is really similar to a move function. The next thing that I want to ask it is, I want to ask it something that is, and I'm not, honestly, I'm not even going to bother to change these inputs on this, since I think we all get the idea. You can change the inputs and expose them in Grasshopper. Move a point. I think for this example, we don't really need, we can spare ourselves. Okay, I'm just going to grab a new Python component. Okay, and ignore that. The next thing I want to ask is, let's say I have a particle on my canvas. I want it to pick a random direction. So decide a random direction to move the particle. And then I want it to decide again a new random direction and then move that particle there. And then we're going to be able to trace this. So it's pick a random direction, pick another random direction, pick another random direction. We call this a random walk algorithm. So I think the first thing is I can ask ChatGPT, just clear all. I'll ask it, are you familiar with the random walk algorithm? Sometimes when you ask it content, and it gave me some Python. That's just cool. So it says, yes, I'm familiar with random walk, mathematical concept and stochastic process. Describes a sequence of steps where direction of each step is determined randomly. So as the name implies, it randomly chooses where to step. Yeah, physics, all these things, it's different applications. We're using it for fun. There's 1D. Okay, that's cool. 2D, 3D. Okay, very nice. So can you please, thank you. Can you please write me a Python script for Grasshopper 3D that implements a random walk algorithm based on an input point number of steps and outputs a let's say it outputs lines, outputs a polyline that connects the points. Okay, random walk is on an input point, number of steps. Let's say a step size. That's important. Kind of. Okay, so this is what I'm going to ask it. Okay. Let's see if this works. I'm going to copy the code. Moment of truth. Control V my code in here. And I'm going to test it. Okay. Math is not defined, so we need to import math. Cool. Okay, so this is more or less randomly walking, it looks like. Looks like it did not output a polyline. Somehow. Okay, so this is kind of a 2D implementation of what random walk is doing. If I change the number of steps to 25 and test it out. Okay, Well, we can just draw a polyline. Hmm. Should return a polyline. Okay. I don't really care. We can just do this. So we will expose the variables for this. But one thing that I'm going to do here, let's see. To answer this question, yes. The nice thing is they can be reusable. You can even, I didn't do this for the workshop, but yeah, I mean, I can just add this is what I'm doing, is adding the polyline, but we can just keep these as 2 nodes instead of 1. And how we can debug with ChatGPT. So if there is actually an error, or let's say in this, I had to add the import math function. One thing, let's just say, okay, let's just pretend like I didn't add that. And I hit OK, and this gives us the error. I could just take this and copy this. Sorry, I kind of jumped around these questions. Back to this question too, you can save user objects. I don't have any saved, but the nice thing is in the files, if I go to open document, all the files that I shared here, like these are all things that you can take, and you can take the Python component and you can just reuse that as many times as you like. Okay, so let's just say I copy the data only from here. This is an error I'm getting. I mean, I kind of know that it's calling math and I need the math module, but let's say you didn't know that. I could say, thank you. I am just getting one error here. And that is, and hold shift, and I can copy the error message directly here. Math is not defined. So maybe it will realize that it needs to import math. And then it tells you in a kind of fun way, don't forget to import the math module. Okay, done. All right, so let's see, copy the code. Let me just replace this code now. And hit OK. And it corrected it for us. So yeah, that would be the process of kind of using ChatGPT to help you debug it. So in this case, it kind of identified right away that it needed to import the math module. And it tells you, do not forget. So I'm going to click off that. So this is a 2D implementation. 2D. So you can kind of control some of this stuff in here. I'm going to go ahead and ask it to implement this in 3D now. So I'll go ahead and delete that. I'm copying this. Let me copy this. And I'll say, thanks. That worked. Can you please modify this script so that it randomly walks in 3D. And I will hit enter. Awesome. So looks like mostly all the same. I can copy the code, go back to Python and Grasshopper here. I'm just going to destroy all of this and then recopy the new code. So it says random walk in 3D, hit OK. And now this is a 3-dimensional random walking algorithm. Pretty cool. 3D. Okay, so I also need it to have a seed. So I could, let's say, write that in myself. But because we're fun and using ChatGPT, I will ask ChatGPT. Thanks, this works perfectly. Can you have it, can you modify the code so I can give it a random seed input seed. Okay, so the code probably shouldn't change much. Interesting. Okay, so it actually added the seed step to our definition. So if seed is not none, random seed, set the random seed. Yeah, we could do it this way. I tend to just put the seed, but that way you can call a different seed for each definition. All right, well, we'll try this. We'll try it this way. Okay. I'm just going to copy it to be less destructive. Okay, so I got to go back. I'm going to copy the code from ChatGPT here. And now I'm going to paste this in here. Okay. I'm using our testing method. Okay, our seed works. So the next step, what I want to do is now I want to expose all of these variables. So, okay, random walk 3D, input point. So the first thing, I probably want the number of steps to be the first variable. So I'll do this as number of steps. And as always, then you want to hashtag that out. Then I'll give the input point. I'll go with the order, whatever. Input point. I could just start with an X, Y, Z point for now. Just start at the origin. And let's give it, okay, let's hashtag that out. Step size, I'm going to control copy. Give that a step size. Hashtag that out. Step size is 1. I could make it 1.5. And then the last one is going to be our seed. And I'm going to put the seed 300 here, and then test. All right, so it screwed up because it got a vector, not GUID, and that's because we need to explicitly under item access, so I don't need to change that. Under type hint, we need to change this to a 0.3D. Okay. Integer got float, so number of steps we need to change to int, and that should correct it. Step size, it kind of knows it's a float. I'm just going to explicitly change it, and the seed, I'm going to explicitly change to integer so it knows. Okay, so I've hashtagged all my inputs out. So really the script is this, and I can go ahead and hit OK. And you can change the number of steps and it will continue to randomly walk. And I can change the seed and it will randomly walk based on the seed. I think I just answered that, I think. So under number of steps, you just need to give it the type hint int. So even if the slider is int, the Python component automatically converts all numbers into a float. So if no type hint or gh doc_object is selected here and there's no type hint for int, it's going to assume it's a float, and you can't iterate like a for loop with a float. So you can't say iterate it to 1.5 or like 10.5. It has to be an integer. If that helps. And I'm going to just share this chat. Okay, so that's why earlier messages you send after creating your link won't be shared. Good to know. All right, so I'm going to copy link. I'm just going to share this in the chat so everyone can see that. Did you figure that out? Did that answer your question? Okay, doesn't seem to work. It could be something in the script that's not quite right. It's hard to say without seeing it. Let me save this real quick. So you should be able to access this and kind of pick up from where we are. And I think you should be able to have this chat access if you want to use this code. I'm just gonna say, sorry, it's not working on your thing. Sort of the nature of this is like, if you're doing it custom yourself, like without seeing it, it's really kind of impossible to know what's going on in your code. Okay. All right, it's 5 till 3 on my end here. We have our random walk. I'm gonna take a 5-minute break real quick and I'll be right back. I'll see you in a couple minutes. Okay, I'm back. Save this. Okay, so I hope at this point the random walk is working for everyone. Okay. We've got our polyline coming out of here. So this is a curve. So this is something, just a minor thing real quick, that the last variable it uses when you plug it in, it doesn't auto name it. So sometimes you just got to give it a little, you add another one and then you subtract. And then it'll name it automatically to seed. I don't know why it does that, but that's, I don't know, maybe it's a glitch that just never went away. Okay, so I actually, the max, I want to change this to like 3,000. Let's like push the limits on here a little bit. So if I got that at 100 and I keep walking it, doesn't really take long. It's just kind of walking it around. Okay, keeps going up. All right, 3,000. It only takes 34 milliseconds. That's not bad. We can kind of change the seed and we got this squiggle. All right, so that's more or less what we want. So now let's take this thing and let's turn it into goop. So we can use Dendro for that. We did Dendro, we did it for points, we did it for meshes. Now let's do it for curve to volume. So this is going to be the same kind of thing. It's going to ask for a radius. It really works exactly like the point to volume component worked. So let's get our create settings. I don't know, distance. Let's put it start high. Maybe start high because I'll save this. I'll do 0.66. Go up to 66. We'll do a little multiplication here. So we know that from earlier, it needs to be 66% of our radius. Let me save that and let me plug this in. Okay. So super not refined at 12. I'll just double click in here. Maybe my max, I want to be 15 on this one. Go 20. And then let's make this a little lower. Okay. So we can go lower, 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 lower. All right. That's more like it. Okay, so we can do, I'm gonna go back to our random box live example. And I'm just gonna copy this stuff. So the stuff at the end here, we had this kind of string definition going on from where we meshed our boxes. I'm gonna go ahead and just copy that, Control-C, and I'm gonna Control-V it in here. It'll be down here. Drag that over and plug my volume into that. Cool. So that's gonna give us a little wobbly thing that's much more smooth. Okay, so I'm gonna just crank this up a little bit so that it doesn't have to be something like that. I'm only doing that because what we're about to do is we're about to add more of these squiggles. So this random walk, I think, how it is now, we could probably change this in real time, and it's going to change, our mesh accordingly. You can change the step size. It'll get even, more refined as you change the step size. I mean, really at this point, the step size is more or less like a scalar for this thing. So I don't know, maybe let's do 2. Yeah, something around good enough. I'm going to save this. So one little trick that we're going to do is, what's cool is if you give this maybe multiple seed values here. So just bear with me. I'm going to copy this. Because this is list, or it's item access, well, if I give it multiple, it's going to regenerate different versions of this based on different seeds. So let's say I have 3 different, I want to give this 3 different seed values, and I merge this in a merge component. I'm just going to disable this for a second here, just in case this doesn't work. Oops, as I intend. Okay, so that's a singular seed value. Let me plug in multiple seed values. All right, so that did work as intended. So what outputs then, it gives us a data tree of the different points based on our input point and step sizes. So the cool thing is, we can get multiple values coming out of here. And maybe I'll just tick down the step size a little bit. So we're dealing with fewer points. Okay, so I can change this independently to get, different ones individually. I could add another one if I wanted to. All right, so now that's 4. Let's see. So we've got 4 different polylines. Because this is grafted out of the polyline, what I want to do is I want to flatten this because I want this all to kind of be merged and mushed together. So I'm going to go ahead and enable this and see. It's not bad. I mean, the more refined you get, the slower it'll be. So it's kind of this nice goopy object here based on some randomness. But I want to do this a little more sophisticated. Like, let's say I wanted to randomly select different values. Basically, I want to generate random seed values here. Like, that's pretty much what I want this to do. I don't want to like control it this way because this is not very flexible. And it's not really, leveraging the power of Grasshopper with dealing with lists and data trees and things like that. So make sure your polyline output is flattened here. Otherwise, this will, it will work unflattened, but it's going to treat all of these as individual meshes. So it's not going to like, they're going to be individual objects on top of each other instead of mushed together and like smoothed together. So if I flatten this output, now that's kind of all mushed into one thing. Okay. So I'm going to delete this stuff. Okay, so now it's just kind of defining a seed arbitrarily. Okay, so I want a random component. Grabbing a random component, you can grab that under tree sequence. So for the random domain, the range in the domain, like one thing I like to do is maybe let's just set this to something high like 10,000, and I want to plug that in to R. So even though it's asking for a domain, it'll implicitly convert a number from 0 to whatever the number is. So you can kind of just create a domain like this. And it saves me some space, and it's going to ask me for a number of numbers, so a count. So if I want to have, I don't know, 12 of these, it's going to create 12, and maybe I'll use this slider as my seed. So now I have random values. So I can just turn this into integer numbers so Python doesn't have to implicitly convert it. So now these are various integers that are seed values between 0 and 10,000 that I can plug into seed here. All right, so that's pretty cool. So I can, let's see how long, yeah, it's taken about half a second, almost a full second to get all of them calculated. And by the way, if you do not use your profiler or have that turned on, I always recommend to everyone using the profiler, which is under Canvas widgets profiler, and that tells you the how much time components take. So it really helps you in determining where bottlenecks are in your script, or like which things might be faster or slower than others. So I always recommend in Grasshopper, everyone, doesn't matter who you are, like use the profiler. It's super helpful. Okay, so I'm not going to drag the slider. It's like a little intense at 12. So maybe I'm gonna, I don't know, change it to like 333. So you can change the seed values and get some different random configurations. Okay. So that's the random walk. You know, I can change the number here. I could like double that, or maybe go up to 30. It's going to take a while, maybe twice as long to calculate, but it's going to give us, yeah, it's going to give us this nice kind of organic amorphous shape. You know, I could change this down. It's kind of change at your own risk. Maybe it'll take a little longer, but maybe I'll change that to 1. Let that roll if I want a little bit more refinement to it. Right, so you can approximate it a little bit closer to your curve geometry. Now if I turn this on, right, we can see it a little bit better. All right, so I mean, this is why we're using Dendro for this part. Give us this kind of nice amorphous type of shapes. The goop. All right, so that's random walk with ChatGPT. Our last step is really getting maybe a even more refined type of algorithm, which is an L system. Let's change that back to 2. Cool. And I'm going to save this. Go back to our shaded preview. I'm just going to enable or disable that and turn this stuff off. Okay, so this is stuff we can reuse when we look at our L system. Okay. Another cool thing to note about this is we can give it any number of input points too. Like we can start the random walk at different input points, but maybe we'll try that out when we start throwing some of this stuff together. Okay. So let us go back to ChatGPT. I think it should have shared this code. Again, I've saved this under organic form live example, saving this here. Okay. Let's start a new chat. We're going to ask it to make us an L system. So I think the first thing, so sometimes what's helpful in ChatGPT and what we've been doing this whole time is ask it for a little bit of context first. So I'll ask, are you familiar with an L system? Cool. So yes, familiar with L systems, Lindenmayer systems. It's a mathematical formalism developed by the biologist Aristide Lindenmayer in 1968. So theoretical framework for studying the growth processes of plants and has been applied to various other fields in computer graphics, art, music, etc., etc. So it's a set of symbols that are building blocks, construct patterns. Like in the case that we want to do is we want these things to make some branching forms. So it uses a set of rules and it uses what's called an axiom. So it's the starting point for the L system. And then it iterates through these to create complex structures from kind of a base set of conditions. Better performance than building up a script manually. I'm not entirely sure what you mean by that, but it depends. I mean, probably not. Typically, like Grasshopper components, because they are compiled already, tend to be pretty efficient. A lot of the components have optimizations built into them for them to run faster. And they're usually done in C# or Visual Basic programming language that compile. And it's typically like, I'd say Python is probably the slowest language that you can use in terms of Grasshopper. So it's not necessarily fast. I mean, there are things you can do, like you can run your script in parallel. You can use things like R trees or KD trees or spatial data structures to make things run a little smoother. But outside of that, I mean, I don't know. It doesn't really matter that much, especially for the stuff that we're doing. But I would say generally, no, it's probably not better in performance. Hope that answers that. ChatGPT to write a script. How do you ask the question? You have to use special words. I mean, yeah, I think part of it is just using kind of the stuff that I've been asking it, like, you know, asking it for Python code in Grasshopper 3D. You might want to ask it. I think the latest examples, it's been giving me more examples using Rhino common instead of Rhino script syntax, which I find to get better results. And just generally, that's a better practice, in my opinion. I mean, maybe the old guard of computational designers would scoff at me saying that, but I don't tend to prefer using Rhino script syntax just because it's like more of a packaged version of what Rhino common is anyway. So anyway, I don't know. Yeah, like you can use special words. There's probably different languages. I don't know. A lot of this is very experimental. So I think, I mean, I'd be curious to see if like other people get different results based on like the language that you use. Maybe, you know, that carries some kind of different meaning with what you get out of it. I will say, I can ask it the same question worded the exact same way, and I will get a different result every single time, because what it is doing is it's kind of like randomly generating that response based on the gist of what you're asking it. So that's something maybe to keep in mind when you're using these large language models when you're asking it questions. All right, well, I hope that helped answer that. Okay. Okay, so let's see if this will get us to do an L system. Can you write me a Python script for Grasshopper 3D that implements an L system algorithm that outputs lines. Okay, try that. Yeah, sometimes it tells you this. It tells you Grasshopper is a plugin and can't do exactly what you think. All right. So, all right, I'm going to take this. Generally looks like it could work. Axiom is F, rules F. Okay, so copy the code. Did use Rhino script syntax, but let's see if this works. Okay, so I have all previews turned off. Got this saved. I'm going to just grab a fresh Python component here, and I'm going to delete that stuff and then paste our code for the L system and hit OK. Cool. There's no error, which that's promising. So it seems like that works. So draw lines based on the L system string. So draw L system lines. What is that actually doing? So sometimes we kind of have to look in here and see what it's doing. So it's doing rs.add line. Okay, so there's really no output, which we probably need to say a equals. And that did not work. Okay, so let's just ask it. Let's say, thanks. I do not get an error. However, I do not get any output geometry to show. Can you make the lines output from a variable, say A? Okay, let's copy that. And I'm just going to delete this code and copy the new code in here. Okay, whoa. That's pretty cool. All right. So it is output our lines. It appears to be 2D, so it's got our rules. It's using Rhino script syntax. Honestly, because this works, I'm not even going to ask it to change that. Whatever. So let's just kind of look at what some of our variables here are. So we've got rules that's defined as these kind of signifiers here. So it's basically saying if this, like that's kind of how the L system is working. The axiom being F here. So it's just looking for F characters and it's looking for different kinds of positions to, you know, change what those rules are. So Def main, I mean, I don't really, we kind of don't want it to expose this stuff in main, but we could say something like, we could expose, let's say, iterations angle length here. So anyway, iterations are for, like, let's say we change the angle to something like 15, test that, right? See how that's going to change kind of like this system here. We could change the length, right? So like these are things that we could start to expose. I think if it's in a definition for main, we need to like expose it out, then create variables for it that main takes in. Let's do that in a bit, but first thing I want to do, all right, so 35, okay, so we can really kind of test that. That's pretty cool. Okay. And this is different than the other ones that I was using before. So we can say this is a 2D L system. Cool. Now let's ask it. Thank the machine. I notice always be kind to the robot overlords. All right. I noticed that this works in 2D. Could you please modify the script so that it works in 3 dimensions? Okay, enter. You're welcome. I'll share the chat after we're kind of done working through. I think what happens is if I share it ahead of time, it won't update again. Yeah, so I'll share it kind of after we've gone through this a little bit. Okay, added new characters. So that's pretty cool. Let's see if it's actually that cool. Okay, I'm going to copy this. So this is like our old version of the 2D output that we had. Let's I'll save. So this, since I copied that component already, I can just eat that code and then paste the new code in here. And let's test it. And it's a straight line. Okay, that is because our vector is only operating in one direction. So I'm going to say to ChatGPT, the output for this, oops, appears to be a straight line in the z-axis. Can you please modify the code so that this branches in 3 dimensions. See, this may or may not work. I don't know. Copy the code. I'm just going to kill this code here and paste it. Interesting. What is it doing in the position? Okay, no change, no change. Well, part of this is the joy of generating. All right, well, seems to be consistently giving us these results. The 2D one seems to be working fine. So that's cool, at least. So let's just go ahead and make the modifications to the 2D system. Let's scrap the 3D one for now. And then we can open the example of the 3D one that I've made ahead of the workshop. All right, so 2DL system, let's just copy that component, get rid of this. Place that in the discard pile over here. And let's expose some of these variables. So main, iterations. So let's say we actually want this to be that iterations. And we're doing this because it created a definition for us. So I'm going to take that information, copy that, and paste that to main here. So that needs to match. Turn that off, turn that off, turn that off. So I'm going to copy, paste, copy, paste. This isn't the glamorous part. And I will copy that and I will paste that. Okay, test, that makes sense because it needs an int. This needs a float and that needs a float. And be careful with the iterations here. We want to probably have lower values. It doesn't have an angle value, so just give it 15 and then a length. Okay. Now it works. Okay, cool. So now we have this thing with exposed variables and line outputs. Okay, so we can play around with the slider for our branch. Adding an extra iteration is going to add, like every new iteration adds, it like multiplies it. So it's exponential. That's just kind of how this works. If I added 5, I bet this is going to take quite a bit of time. Yeah, so 5 takes almost a second to run. I'll just save this. So you got to be really careful with the iterations when you're doing L systems, because that can really screw up what you're doing. Yeah, so this is added, 32,000 curves here. Yeah, so 30. That's pretty cool. Okay. So you can also change the rules. Like you don't have to keep these rules the same way. So one thing that I could do here is I could copy this. Maybe I paste that and I hashtag that out. All right, maybe I want that to be a minus. Maybe I don't want that to be a double F, but a single F. I don't know. Maybe I'll add a plus here, minus. Maybe I'll put an F on the outside there. And maybe that's, maybe that one's a minus. I don't know. Test. Okay, so it definitely did something super weird, but gave us something interesting that's different. Looks like it. If I change the angle. All right, so that kind of made it like a bird basket. That's kind of cool. Anyway, I'll go back to the previous axiom or the previous set of rules. It's a little cooler. All right. So that is that in this example. Let's see here. Open document. So all of these were examples that I had before. Let's just open up this L system example here. I think when I was asking it to do this in 3D, I was asking it to like randomize the vector that it branched off of. So it generates the L system, and then it branches. I have the Dendro curve set up so I can enable that. And this creates the curves. Let's see. I can also take that and just paste it in here. Okay, so another one that I want to show you is one thing that I went through and asked ChatGPT is to give me a list of rules. So this one's doing the exact same thing as the one that we just saw, but I wrote a secondary Python node that I basically asked it to give me a list of axioms or a list of rules for the axiom. So it's got a list here, and it outputs the rules so that it's in a format that the branching L system component can read. So, here's some example rules that were already kind of set in. I was playing around a little bit with it. But then I basically asked it to take in the rules and take in input rules from here. So I can change the seed value or the slider value. And you notice here in the panel, it's going to change the number of rules. So I can copy this and put it into our live example. Oops, not that one. Organic forms. Just move that down here. Okay, I'll turn some of this stuff off. What's cool though is like you can see that different rules give us kind of wildly different results here. I guess maybe a way around what we were trying to work with the L system in 3D, we could ask it to like randomize some stuff for us. But yeah, as the rules change, they get kind of more simple as the slider goes down. But you get different results. So let's say you liked this rule set. You could change the number of iterations for that particular rule set, and then you could change the seed. So give it different random configurations for the L system. Okay, so as promised, I will share this chat. Oops, in the chat here. Okay. So that's pretty much what we've got going for ChatGPT. Like we've done a random walk, we've done an L system. I mean, there's other types of algorithms that we could prompt it or ask it to do. I think, for now we can get pretty good results that kind of follow some of the visual language that we've been working with just like these basic systems. So one thing we might want to do is put some of this together and like start combining some of these techniques. Okay. We got about 20 minutes left. I'm going to take some of the technique from this live example here. And I'm just going to I'm going to start a new document. Maybe we want this to show up. Okay, I'm going to save this. Let's save this as putting it together. Okay, so we got our boxes. We want to get some of our else systems, our random walk. Okay, so let's get this random walk and let's work with that. So I'm going to copy that and plug this in here. So just going to disable this stuff. Got that. I'm going to enable this one. Okay. So let's say I'm working with this boxy form and maybe I want, so right now I have 30 for my random walk. Just enable that. Maybe something that I might want to combine in this is I want the random walk to be walking off of this mesh geometry for our buildings. Or maybe I want it to be working off of this one. So maybe I actually want to increase this radius to something like 75. All right, so maybe more spaces with our box. Just turn that off for a second. And then maybe these values I want to be much larger. All right. I'm just kind of tweaking the values right now and playing around with this. Maybe I want this at 120. Okay. So I'm going to take this population points. Maybe I'm going to copy that. Maybe I want fewer of these back to like 40. Okay. And I'm going to take these points over here. I'm going to drag the random walk stuff over here. So I'm populating this form. I've kind of refined it a little bit. Right now, this has 30 going into our random. So I'm just going to disable, and maybe I'll just turn this down to 15 so it's less contentious. So I'm going to put this slider into here. Okay. And then where our input points are, instead of using our origin point, I'm going to put the populate geometry points into our input points. Okay, so now we're randomly walking these things on this shape. Okay, so maybe I'll crank the value up here to 45. Okay, so now we have these like squiggles pulling off of our mesh. Chat. Thank you. I'm glad you enjoyed it. Okay. So we have our mesh here. I'm just going to take that and bring it over here. I'll save this. Okay, we have our little boxes. Yes. Keep going. Push it further. Okay, so our points, what we could do here is pull them to our mesh. So one thing we could ask it to do was do a random walk on a mesh, but because this is all random stuff, we could just take those points and then pull it to our mesh. Basically, it might take a little bit. Yeah, about 3 seconds. That's fine. So now that this is set up and this takes a little while, we just want to be very mindful about pulling the sliders. You probably at this point want to select into the sliders instead of dragging them. Kind of, especially when you get more geometry, it's a bad idea to drag sliders around. Okay, so now these are the points. We're going to plug that in. So now these things are going to be more walking along the mesh. Okay, cool. So we got this stuff kind of going along the mesh. One thing that we could do is we could take these points, we could mesh closest point. Which maybe we actually do instead. We'll plug the points in here, the mesh. All right, that's a little faster than our pull. Okay, let's not use the pull point. Okay, so we got our points, we've got parameter on the mesh. So one thing, we could play around with some more randomness. I'm honestly just kind of winging this here, so bear with me. I'm gonna pull this out a little bit. I'm gonna create a vector between this and that. And I'm gonna give it an amplitude. I'm going to use these seeds here since we've already kind of generated some random seeds for each value in this list. And I'm going to get a random component. I'm going to go ahead and graft the seed here, plug that in. The number of values I want to be the list length of our points here. So 1570. 1570. So that's going to be our number of values. Basically what I'm doing is I'm going to move these randomly off of our surface so it's not like so flat on here. Like I don't want it to be kind of all squiggly out in the middle in the air, like, you know, that's coming straight out of the random walk. What I want to do is I want to kind of conform this a little bit better to our shape. So it's, you know, but it's also sticking out. Like I kind of want the qualitative effect to be more like this on a shape than, you know, squiggles coming off of it. Okay. So random, random, and then I want this. Let's have some control over this. We can do like 12.50. This is where we get a little bit sloppier. Maybe that's extreme. I don't really know. Okay, so we got our value list here. It's in a nice data tree. That's in a nice data tree. This is going to be the amplitude of our vector. And I'm just going to move these points off of our mesh here a little randomly. Maybe that's at 0. You could even make it negative if you wanted to come into the surface. Okay, maybe I don't want it that much. Get a point output here. Just go ahead and save that. And I'm going to plug that into our polyline. And let's see it. All right. A little bit better in terms of its conforming to our shape. It's taking a minute. I think we could change this value down. I'm going to disable the solver really quick. I'm going to shrink this again a little bit. 200, 200, 200. Enable that. All right. Cool. Sometimes the preview goes away. Maybe turn that to 70. All right. That's pretty interesting. So that's our mesh. This will take a bit, but it's probably looks better if I change that down a little bit. So I'll save this, change that to like 1.25 here. Let that wait. I don't know. Can try our best to share that. I'm hoping generally like what gets out of what you get out of this is largely the concepts behind this and able to follow along in that way. All right. Let's change this. Okay, so yeah, we kind of got these squiggles. Now we've got our boxes. Maybe let's ignore the boxes for now. And then some of them are kind of inside our shape. All right, so that's the volume. Let's go to Dendro real quick, and I just want to show like one last little thing of how we can actually combine this mesh that we're creating our shapes on with this mesh here. So we can actually kind of work with those together. So I'm going to get a volume component. Turn my mesh off. All right. And then I'm going to get the curve volume. So that's these here. Let me just turn that off for a second. So I got this volume and I got that volume. So one thing that I can do is I can merge these volumes together. All right. Okay. And then I just want to flatten them because I want them both to be exposed in a flattened list. And let's say want to intersect these. So let's give it a volume union here. And I'm going to save it. This might take a second. And I'm going to volume union these two things. All right. So now I have this volume that has combined our original Dendro volume, which is the form that we're working with our new squiggly random walk volume. So I can now take that and plug that in here. This will take longer, so we can kind of smooth it out. Okay. Cool. Interesting, it kind of wonder if I do this. Kind of makes it a little jagged. Maybe doing that in the volume union. Anyway, now created this kind of bumpy texture on the knot. So got that volume, you know, we could even apply it. I could plug this volume in instead. Oops. To let it sit. Right now, some of this, like, you can play around with it, refine it, and a lot of this just is plug and play. Okay, so now we have our box geometry with some pretty interesting tendrils happening in between it. So I think if we change this, oh, super weird. All right, so some of this, it like makes it kind of chunkier. Probably has to do with the volume union intersection, but still pretty interesting. Yeah, maybe I make it like a 4. So, you know, these are just some of the ways you can kind of use the AI. You can use, you know, ChatGPT, and you can use other just native Grasshopper techniques to build cool and interesting formal ideas. You you know, this is one way the last like several months that I've been playing around with this stuff and, you know, sketching through ideas, playing with them. Like we can kind of take this, if I disable that, right? Like we can now take something like this, turn that stuff off, and I could use this as a screenshot into Stable Diffusion. Yes, it is a closed mesh. So let me bake that. There we go. And Dendro always gives you a inside out mesh. So that's something to think about. Okay, I just flipped it and now I have this. So this is baked mesh. You can use this if you wanted to. You could take this and you could 3D print it. So I'm saving this file. Awesome, thank you. I am glad that you all enjoyed it. Okay, so yeah, that's a mesh. Just gonna delete that. Let's see, what's our time looking like? All right, we're 5 minutes over, but if you care to stay on for a second, let's just like throw this into Stable Diffusion real quick. Why not? And I will save it as model screenshot example 3, save. All right, back to Stable Diffusion. So instead of this, images, let's throw that there. I'm going to use the depth model, see if that gives us something interesting. Let's let's keep that and let's generate. We'll put this back at 20 and let's generate. All right, cool. Well, pretty unsophisticated. It seems to think, I think some of this like the more biological looking stuff is trees, which is interesting. I wonder, image to image. Let's go back to our cyberpunk. Maybe I'll use this and then since this was already up there, then we can use, I'm just curious real quick what this will look like. Pop that into Stable Diffusion, ControlNet. Let's use, yeah, we'll use Canny. Let's change this up. 1000. 24 by 5. All right, let's try this. So another thing that's cool is we can take some of the Stable Diffusion stuff. All right, that's kind of interesting. Not quite there. The control weight is 1. Let's see what the canny looks like. Because it's pretty nondescript and amorphous. So if you can get more contrast, sometimes going with depth can give you a better depth result. Let's try again. Interesting. Let me add one thing to the text prompt. Cables and tendrils. Organic. Biological. And coral. Let's see. Maybe just one more round. All right. It's pretty cool. Added some cables in there. Yeah, so another thing that I might do with this is, like, let's say I get some stable diffusion results that I like. The way that I got this image in MidJourney was actually taking some of the stable diffusion examples and then putting it into MidJourney. So this is kind of the last step, is we start with MidJourney, go through ChatGPT, through Grasshopper, take screenshots, render in stable diffusion, and then we could put it back into MidJourney and like complete the cycle and go full circle and just kind of like metabolize ourselves here. So I'm going to use this stable diffusion example that I had made before, since it's a little bit higher quality than some of the other stuff. So one thing that I can do is I can take that image and I can throw that into the chat bot in stable diffusion or in MidJourney here in Discord. And I can upload that. And what we do is we copy the link. So when I go to imagine here and copy the link here and just say a cyberpunk city scene. And then match the aspect ratio 3:4 and enter. So now this will generate in MidJourney some variations based off of like the qualitative aspects of this image. Of course. Welcome. I'm glad you enjoyed it. Yes. All right. So pretty interesting results based on some of the qualities from this image. I can just upscale all of those. And we've come full circle. So now I've upscaled these. So I've kind of gone from, let's say, our 3D model where we'll have something like this, rendering it out in stable diffusion. So we've got stuff like this that matches our model, more or less, and then bringing that back to MidJourney to give us more riffs and iterations off of that image with some more detail and other things that we might not have thought about. So thank you all for attending this. I appreciate all who listen in. This is kind of the gist of it. We come full circle, starting with an iterative diffusion model in MidJourney, and then ending back.
Awesome webinar, Alan. Everyone really enjoyed it. As you can see from the comments.
Thank you.
Yeah, very cool. Very on the edge kind of stuff, you know, and actually went a lot smoother than we thought it might. So.
Yeah, I was pleased. I only had to bring out the examples like once or twice.
Yeah, you never know, especially any of you guys planning to play with AI. I mean, VRAM is a very big deal.
Yes.
So, you know, you have to get the right equipment and the right tools if you want to get like serious with these things. But yeah, innovative stuff, and all of you should stay up to date with it because it's changing every day. And make sure that you follow Alan, and also if you make anything cool, anything interesting, share it to your socials, tag us, tag Alan. We'd love to see it and reshare it as well.
Yeah, please share.
Yeah,
love to see what you guys do.
So in the recording, I'll give all these links also, and the Dropbox stuff. But I'm curious, the ChatGPT link won't work after some time, right? It will kind of disappear.
I think so.
Yeah, it kind of like has a limit of cache or something, right? And so yeah, if you guys want that, you should, I don't know, copy and paste it somewhere. We just discussed that. I printed them as PDFs. There you go.
All right, cool. That works.
Yeah. So that works. Yeah, that's cool. But also, you should just use ChatGPT and get to your own kind of results. I think.
Yeah. Please play around.
Yeah. So thank you, everyone. I think we'll end this webinar here. Thank you, Alan, for a great webinar. And until next time, just a reminder that we have 2 webinars next weekend too, and one of them also is with AI and stable diffusion and all that fun stuff. A bit different webinar, more about like going from like AI to 3D model kind of stuff. So if you're interested in this topic, there's another one next week using AI. So yeah, thank you all. Let's end it here.
Cool. Thanks, everyone.
See ya.
All right. See ya.